Hi, hello everyone. मेरा प्यारा warriors, आप सब लोग कैसे? I hope you all are so good and happy because here we are to witness an amazing session where in the session we are going to cover the entire theory and the multiple choice question of this chapter, Newton laws of motion. And I hope you all came prepared to the class. The class is going to be a bit long. Okay, it will be a very chill pill class. We'll be going very slow. Okay, just like listening to some soothing music, and it is going to be a bit long. So whoever wish to complete this particular chapter of laws of motion revision and to get a very good mark for your term one examination, this is your class. Okay, so whoever is seeing me for very first time, this is your Ameer Bhaiya, physics educator at Unacademy. If you all can see me and hear me, jaldi se jaldi fatafat give me an amazing thumbs up in the chat box. Everyone. Pal, Ayush, boom. So yes, I'm so much audible and visible. My voice is clear. I hope every one of you can listen to me. Yes, Devik, I had my food. Thank you so much for asking. Good evening, good evening, good evening, Sapna, Thanushri, Ishita, Ankit, Shreya, Kunal, Miara. Very good, very good. So I hope you all know how the session is going to be. I hope you all came here after having the dinner, है ना? So if my health permits, if I am going to be healthy throughout the next 4 to 5 hours, right? We'll be covering this entire session for within that 4 to 5 hours, right? Good evening, Shreya, and good evening to everyone in this classroom. Whoever is seeing me for the very first time, a brief introduction about myself you can see. I have an experience of more than 3.5 years in the field of teaching. JEE, NEET and board student. I am a beta graduate from NIT Calicut in mechanical engineering, right? And if we proceed further, right, this is the schedule and in this week, the only thing that is left on 3rd of October, we'll be having a similar one-shot class that is for 12th standard, which is alternating current. Okay. Now, you know that amazing teachers are there in Unacademy Class 11th and 12th YouTube channel, right? And I know that you all wish to learn with these teachers live. And if you want to catch them live, if you want to get notifications and alerts at the same time, you can come and join and be a part of this Telegram channel. The link is given right here. Jaldi se fatafat, we all are expecting you. Then I know that you all might be knowing this simple thing that the Unacademy family, that amazing family, it would be an amazing opportunity for every one of you to be a part of it, right? And to start learning with this and preparing for all your examination. So we have the scholarship test happening on 3rd of October at 1 p.m. If you're going to get an amazing mark for this, you can be a part of this Unacademy for completely free. And the code which you want to use while enrolling for this is AMB10. So use this code while you enroll for this scholarship test, and while you use this code, this scholarship test is going to be completely free. बिल्कुल free हो जाएगा. Then after 2 minutes of me explaining regarding the subscription, it will be just me, loss of motion, and you all warriors. ठीक है. Now सुन ले. Why Unacademy subscription is so much important nowadays, though everything is available for free in YouTube. है ना? I know that is what your thought is. As I have tell you, in the Unacademy platform, we all educators will be teaching with a proper schedule. And we'll keep in mind that whenever we teach, we'll be teaching each and every topics in order, right? And when everything's are in order, you can keep track of all the topic that is being taught to us. And once all these things are there, the entire process of learning will become super simple and learning pe maza bhi aa jayega and you will start learning more and you can grab amazing marks for all the examinations you appear. One thing, top educators of the country are already there with the Unacademy platform. So if you start learning with them, who's having a very good experience in this teaching field, they'll be telling you, right, what is the kind of examination pattern, what are the kind of questions you should be expecting. So once you follow these orders and go in that right path, don't you think you will be ending up in the colleges whichever you are dreaming about? Isn't it? Yes, it is. Study materials will be given to you. Practice test and live test series will make you super and duper confident and will bring out the best from every one of you. And as you can see, for 12-month subscription, it will cost you 1,250 per month. And the code that you have to use for getting extra 10% of discount is AMB10. Okay. And many of you love to learn with an academy with so many features. So if you want all the features of plus subscription and extra some features, you should be going for iconic subscription. Here you will be given a personal mentor. Matlab, someone will be there to help you related to your academic activities 24/7. He'll be telling you how to make the schedule, what should be your strategy for your studies, and which all topics you should be covering. For everything related to your academic activities, this person will be there. After this person is assigned to you, the only thing that you have to do is then, okay, the learning process. Rest of everything planning, this person will be taking care of. Live doubt solving classes will be there. Weekly reports will be given to you. With all these amazing features of iconic subscription, for 12 months subscription, it will cost you 2,333 per month. And those who are like, or those who love discount, you can use this code of AMB10 as a referral code and get 10% of discount. But this is it. And if you're going to make the subscription before 4th of October on this Monday, and there is an amazing offer going on for 12 month subscription, you will be given extra 4 months free. So I think this is the best time. And one more reason, if you start learning right now, if you start your syllabus right now, this is the best opportunity. You can complete your syllabus before all of the examination, even let's say term 1 examination, right? So start learning. You don't have to thinking, or let's say stop thinking and start acting, right? Okay, good. Now it's time to start with our studies. Tell me, are you all ready for this? And let me tell you, I have to go for the next 4 hours to 5 hours of class, so I'll be talking very low, and I'll be making a very chill pill class. I'll be talking in a very small voice. Nahi to after 2-3 hours my voice will be gone ऐसे. ठीक है? So it is your responsibility to come to the class on a serious note, with a notebook, with a pen. Start noting down each and everything. We'll be doing questions, and questions will be done as a mentee. And so if you all are ready, we can start. Jaldi se bol de. So we all are ready. And let me tell you, how many are here to be with me for the next 4 hours and to learn this chapter? Ready? बिल्कुल ठीक है. बोल दे. How many are here to learn with me for the next 4 hours and complete the revision of this particular chapter? Ishita is there, I can see. Pal. Then Roshan. Then who all we have? Anuj. Anupam. Tanushri. Gaurika. Sana, good evening, good evening. Welcome to the class. Miara, Pal. Okay, so, yes. So I can see so many people. Okay, so yes, let's see how it goes. So, at the beginning of a beautiful chapter of Newton's laws of motion. Which were the chapters before this laws of motion in your NCERT book? It is 1 dimension and 2 dimensions, right? And in those chapters, we were only dealing about the motion of a body. We were not talking how that motion is being produced. So it is this particular chapter of laws of motion, we are going to talk about that course which is producing the motion of the body. And everyone knows without any introduction what I am talking about. What it is? Yes, I am talking about, really sorry, I am talking about force, right? So the force is the actual cause for the motion of a body. First, let us have small insight what force can produce to a body. देख ले. If you have a body at rest, if I apply some force on the body, what can it happen? Yes, it can make or move a stationary body, right? Then a body was moving with a constant velocity towards right. So if I apply a force towards left direction, yes, I can make a moving body stop. The second thing a force can do. Then think that I'm such a powerful person, right? And my fist is like the fist of an Iron Man, let's say. And if I give a huge amount of force to this particular block, I can also change the shape of the body. Change of shape. And one more thing, it is not necessary that Sometimes if we apply the force, the body has to move. Sometimes force can only produce a tendency for the body to move, in which case, let's say this particular body of mass m is resting on a surface, right, where there is huge amount of friction, and to this body, let's say I'm applying a small amount of force. Will the body move? Because of the friction existing between the surfaces in contact, the body will not be moving. But here, what this force is acting as? Yes, it is producing a tendency for the body to move. Is it actually making the body to move? No, it is not able to, because a huge amount of frictional forces available. So these are the things a force can do to a body. It can move a stationary body, it can stop a moving body, it can change the shape of a body, or it can produce a tendency for the body to move. These are about forces. Okay. Now let's see what are the main 4 forces that is available in the universe. We know that, or we might be knowing different kinds of forces, right? But all these forces are the subcategory of this 4 fundamental forces which is existing in this universe. Which are these 4 fundamental forces? Gravitational force, electromagnetic, strong nuclear, and weak nuclear. I'll give you a brief introduction about all these 4, but the very first one we need to be knowing in depth, because throughout this chapter we are going to be using about, or we are going to understand what is gravitational force. ठीक है? What is gravitational force? सबको पता है. Gravitational force in general is actually the force existing between two masses. But we are not going for that particular part or that aspect of gravitational force in this chapter. We are only going to discuss about, or that aspect is only required, the earth with its big mass of m, and near to the surface of the earth, let's say there is a body of small mass m. So obviously the gravitational force acts on this small mass of m, right? In which direction? It will be vertically downward toward the center of the earth. And this force, or this gravitational force given by the earth on any body of mass m close to the surface of the earth is found to be having a value of mass of the body into the acceleration due to gravity. G, we call it as acceleration due to gravity. Those who don't know, the value of it is 9.8 meter per second square. And sometimes we used to approximate it as 10 meter per second square. Actually, the weight we feel whenever we are standing on the earth, we feel our weight. This is simply because of the gravitational force experienced by us. देख ले, whoever is having any doubt, this is earth, this is a body of mass m. Let's say my mass is equal to 50 kilogram, right? How much is the force experienced by me? The force experienced by me will be equal to mass of the body into acceleration due to gravity, that is 500 Newton, which means the earth will be pulling me downward with a force of 500 Newton. Okay, so this is regarding gravitational force. A huge thing is there to be learning about gravitational force. We already have started with the chapter of gravitational force. Who used to come to my regular classes might be knowing, but here we only need to know this part. Okay, done. Next force is electromagnetic force. All these forces we won't be using in this particular chapter, but I'll give you a brief introduction. Electromagnetic force, split this into two words, electro and magnetic. Electric force सबको पता है, the force that is existing between positive charge and negative charge, or positive charge and positive charge, that is electric force. So what will be magnetic force? Without me giving any explanation, सबको पता है, the angles between the the force that is existing between the magnetic dipole, north and north, so south and south. Like poles will repel, unlike poles will attract. ठीक है. These will be not so much known to you, and you don't need to know about strong nuclear force or weak nuclear force in 11th standard. A shorter introduction I can give you about this. Okay, strong nuclear force, देख ले, ये हमारा nucleus. ठीक है. Inside the nucleus, what do we have? Inside the nucleus, we have so many protons and neutrons. But Protons are what charged? Positive charged. And what happened between the positive charges? There will be huge repulsion between this. Huge repulsion will be there between the positively charged protons. So, in order to keep these protons inside the nucleus confined to a very small phase, there should be another force existing and which is holding all these protons and neutrons inside the nucleus, and that force is called as strong nuclear force. So this force which is existing between the protons and neutrons inside the nucleus, in binding them together and keeping them into a very small space, we call it by the name of what? Yes, iska naam hai strong nuclear force. So note it down, it's very important. Okay, then weak nuclear force, that is for you to least to study for the time being. Let me tell you, I hope you know radioactivity. What is radioactivity actually? Radioactivity is a process of disintegration of unstable nucleus, which you will be learning in 12th standard, right? So during the time of radioactivity, from the nucleus, so many sub-nuclear particles such as antineutrino, neutrino, all these will be expelled out during the time of radioactivity. A small force exists between them, and that is called as what? Yes, weak nuclear force. All these things are not required for this particular chapter, but a brief introduction I just gave you regarding the four fundamental forces of universe: gravitational, electromagnetic, strong nuclear and weak nuclear. And which is the weakest force? That force given by our mother earth, gravitational. And which is the strongest? Just like the name suggests, it is a strong nuclear force. Then we have electromagnetic, then we have weak, and then we have a gravitational force. This is the order. ठीक है, देख ले. Then forces, okay, that was the four forces existing in nature, fundamental forces, right? So among all the forces that we are going to use in this particular chapter, okay, forces are actually divided into two, as contact forces, non-contact forces. Should I be giving you an idea or a definition for what is a contact and what is a non-contact? I don't think so. देख ले. You have a body of mass m, है ना? Body of mass m. On this body of mass m, if I am applying a force by actually or physically touching this mass, that kind of forces we call it as contact forces. And non-contact forces, okay, the force that is applied on a body without having a physical touch. The best example is what? The weight of the body or the gravitational force. So the only non-contact force which we'll be using in this particular chapter is gravitational force mainly. Okay, do we have does the earth have to go and touch that mass? बिल्कुल नहीं, है ना? So even if it is very far away, this force can be applied on the body. So this is a non-contact force. Under contact forces, can you see so many forces? Can you see all these forces? All these forces we have to, this force is not there. This is for 12th standard students. Okay, so normal force, spring force, tension force, all these forces are important and very frequent forces we'll be using in this chapter. Okay, so let's start learning one by one, and let me tell you, please listen to this initial parts, which is very important. Normal force, spring force, tension force, I'll be explaining only right now, and throughout the chapter I'll be using this normal, spring, tension. At that point of time I'll not be explaining why the direction of normal force is like this, why the spring force is having such a kind of a value and all. Okay, so it is your responsibility, and please note it down. Okay, contact force we already have explained, gravity is done, normal force. देख ले. We have a body of mass m, and this is a table, let's say, right? And whenever this block of mass m rests on this table, this block of mass m will be pushing, isn't it? A pushing force will be given by this block of mass m on this particular table, let's say, and this pushing force existing between the surface itself is called as the normal force. Okay, so mass m will be pushing this table in the downward direction, and this is called as normal force. And I know what you all are thinking, sir, why the name normal? Because this is the surface in contact, and normal force take this down inside your memory in your book very clearly. Normal force is perpendicular to the surfaces in contact. It is not vertically downward. I know that many of you have this misconcept that the normal force is vertically downward. This is completely wrong. This is not the right one. The normal force is this. Let's say this is a surface. It will be perpendicular to the surfaces in contact. Okay, I'll give you an idea. Inclined surface, right? A block of mass m is resting on the surface, let's say because of friction or whatever means. That's not our point. Can you tell me what will be the direction of normal force? Is it going to be like this, just like the number 1 says, or is it going to be like this, just like the number 2 says? What should be and what will be its direction? Jaldi. I'm not looking into the chat box. Before, if I keep on looking into the chat box, this class will be a never ending class. बोल दे whether it is going to be the first one or is it going to be the second one. First one, Ankit, सोच कर बता. Is it the first one? Is it the first one? How many times I have told you? अरे देख ले, look at the surfaces in contact. This is the surface in contact, right? And what is the direction of this normal force? Just now I have told you. Normal force is perpendicular to the surfaces in contact. This is the surface in contact. So isn't this the one which is perpendicular to the surface? The second one. है ना? है या नहीं? बोल दे. बोल दे. हाँ sir, बिल्कुल. Yes. So this is the direction of the normal force. So however may be the direction, ऐसे, 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 just look into the surface and draw the perpendicular to it, and that's how the pushing forces will be acting normal to the surface in contact. Very important. Very, 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 very मतलब super का, duper का, ऊपर का important. So what is SDU? SDUI, super duper का, ऊपर का important. ठीक है. Noted this down. Okay. One more thing I'll tell you. I know that I haven't introduced you to Newton's third law of motion, but you might be knowing, है ना, what is Newton's third law of motion from your 10th standard classes or chotu classes. If this block of mass m is pushing this table in the downward direction with a force of normal n, what is the force with which the table will be pushing the block? With the same force in the opposite direction. Every action has an equal and opposite reaction. I'll be explaining you about third law of motion there while I teach. But for this particular thing, I hope you can understand from your, let's say, 10th standard knowledge, right? Block of mass m is pushing the table in the downward direction. Every action has an equal and opposite reaction. So the table with the same force will be pushing this block in the opposite direction, which means upward. So keep this in mind. Fine. Normal force is done. A retention force, tug of war. Okay, now we can draw actually another figure. देख ले, this is a wall, okay, a foam wall. We have a string here, ठीक है? So we have a string, we have a foam wall, and a block of mass m is connected to it. Understand the concept of tension. Wherever we are in this chapter, I'll be using tension. ठीक है? So listen right now. And don't ask me at that point, sir, why you take the direction of tension in that way? Directly. To this block of mass m, I'm applying the force F. समझ में आ गया? I'm applying this force F. So this force F will be pulling this mass towards right. And this same existing force or the external force will try to extend the string. है ना? This force will try to extend the string. Tell me, to this Mother Earth, if some aliens come to attack us, what we will do? We will resist, है ना? We will resist, obvious thing. Similarly, if you are applying an external force to this block of mass, which is connected to the string, what this external force will be doing to the string? It will be trying to extend the string, which means it feels like the external force is trying to disturb its equilibrium position, or it is trying to extend it. So what will the string will do? The string will hardly resist this extension. How? By providing another force, and that force produced inside the string in order to resist the expansion or extension of the string, we call it by the name of tension force. And keep this in mind so that you won't be having any trouble in understanding the direction of tension. Tension is a pulling force. I know that many of you might have even heard this word. It's a pulling force, it's a pulling force. But still you might not be knowing what this pulling force means. देख ले, I have a, अरे this wire is connected. ठीक है, बाप रे मैं क्या किया. Okay, देख ले. I'll take my phone charger. Okay. Consider this as a string. Tell me, with this particular string I have, can I push my palms? Never. The strings cannot push any body, so the tension force produced cannot be pushing this block of mass m, which means this tension cannot push this block of mass m. It can only pull the body. है ना? देख ले, if I connect the string to my finger, if I pull it, right, what is the direction of force? It is a pulling force. It can only pull the body, it cannot push the body. By using this concept, can you tell me, at this point, okay, which means at the point where it is connected to the wall, the direction of tension, is it going to be in the one direction or in the direction marked as 2? Tell me. बोल दो ना जरा, जल्दी से बोल दे. What will be the direction of tension at this point, right? Whether it is according to the direction of which I have marked as 1 or the one which I have marked as 2. Ritima, Archie, Anshiga, Ani, Deepak, Myara, Sai, Mani says it is 1. Okay. Then Sampunath says it's 2. Myara says it's 2. Sampunath 2. Yes. Pal says 1. Then NTA. Then Devika. Devika says 2. Preeti says 2. Just now I have told you, right? The tension force can only pull. Arey, you just think. This is the wall. Okay. This is the wall. And this pen is my string. What is the direction? Let's say the pen is connected to my palm. So what is the only direction in which I can apply the force on my palm? It can only pull the body, right? Similarly, this string can only pull this particular wall. In which direction? Towards right. If someone has choose the direction of 2, it is the pushing direction. Can the string push this particular point? No. It is obvious. Just use this common sense and think. Bus. Okay. So the direction of tension here will be in this direction. Okay. Very important, the direction of tension at each point. Just keep this in mind. This will be more than enough, which is a pulling force concept. ठीक है? Okay. बढ़िया. Next is spring force. Another important. Let me tell you, all these terms which you are learning right now, you will understand how much important it is while we start doing the problems. So we have a wall, okay, and to this wall we have a spring in its equilibrium length, and at the end it is now spring, it is not string. We have a block of mass m. To this block of mass m, I am applying a force towards right. If I apply a force towards right, what happens? Everyone knows. Spring, if I apply a force, the spring will be expanding. And now let's say, from its equilibrium position, the spring has extended by a value of x. If I extend the spring and keep it here, and I know that everyone might have used a spring, so I have expanded the spring and my hand is here. Let's say I'm only expanding the spring by pulling it. Okay, so I'm just pulling it like this and I have expanded. Those who have played with this spring might be knowing, will there be a force experienced on your hand? Will your hand be experiencing a force if you pull the spring and keep it in its extended length? Yes. In which direction? In which direction your hand will be experiencing a force? Won't your hand will be experiencing a force towards the left direction? What is the spring trying to do? the spring is actually producing a force inside it so that the spring can take back or come back to its equilibrium position. And this force we call it as restoring force of the spring. What is it? Restoring. The spring is trying to restore from this extended length to its equilibrium length. That's the reason why when you expand the spring will be giving a force in the opposite direction on our hand. One more question. Let's see what is the equation of this restoring force, right? Or Fs, the spring force. From this position, okay, from the already extended position, I'm going to extend the spring more now. Initial extension was x1 and now the extension is x2. Can you tell me in which position, whether it is in the position of x1 or in the position of x2, your hand will be experiencing a more force, which means if you expand the spring a little, or in the case of more amount of extension to the spring, you cause to the spring, where your hand can experience a large restoring force. Where can you experience? Obvious, right? Whenever you make a larger extension, the restoring force produced inside the spring will also be more. Matlab, if the value of x matlab how much it has extended. If the value of x is more, x2 is greater than x1. When the value of extension produced in the spring is more, the restoring force produced will also be more. So what is the relationship between the displacement inside the spring and the restoring force? Directly proportional, isn't it? So once we make more and more extension, more will be the spring force. Tell me one more thing. What is the direction of restoring force? It is towards left. We already have mentioned, isn't it? What is the displacement happening to the body when it's say x1 or x2? The body is getting displaced towards right. The value of x is towards right. Restoring force is towards left. So Fs is directly proportional to x, or Fs is proportional to minus x. Which one is true? Which one we can say that true in the case of the restoring force? Is restoring force directly proportional to x or minus x? Minus, because restoring force is towards left, the displacement is happening towards right. So Fs is directly proportional to minus x, and restoring force or the spring force is equal to converting proportionality into an equation by multiplying it with a constant, and this constant is called as what is this k value called as? Spring constant. समझ में आ गया? Okay, so if you try to explain what this spring constant is, k is Fs by x. The magnitude of k is Fs by x. So how will you explain verbally? That is the restoring force produced per unit extension. Matlab, if you make 1 meter extension to the spring, how much force is produced? That is defined as the spring constant. बस इधर तक समझ में आ गया? Is everything fine till here? Sonam, Tanushree, Mohit, Harsh, Myara, Ayush, Sasta, Amrita. Yes or a no? Is everything fine? Very good, very good, very good. I hope you all can hear me and see me, right? I hope you all can hear me. Is my voice audible to everyone? I know that I'm talking a bit less because if I keep my voice high, I won't be able to complete this big session. Perfect. Yes, yes, yes. Badhiya, badhiya, badhiya. Tell me how many of you are, or how many of you have noted down everything whatever we have completed? Jaldi bol de. Ritama, Anupam, Shreya, Myara. Bol de. Are you all noting down all these points which we are discussing? Yes, I'm audible. Thank you. So everyone, yes, Sujal, Kaivalya, Harsh, जी सर, noted. ठीक है, बढ़िया बढ़िया. Okay. Now we are going for the easiest part of this particular chapter. The reason why I say easiest is because the moment I say, or the moment I ask you, students, my values, what is Newton's first law of motion? Everyone will start yelling out. So, Newton's first law of motion, everybody continue to be in the state of rest or state of uniform motion until and unless an external unbalanced force act on the body. Now, everyone knows this particular concept, right? So those who have attended my classroom, I have explained this well. No worries, I'll be explaining the inner concept of what this Newton law of motion means. You can understand this if I ask you a simple question. Dekh le. You have a body of mass m which is at rest. According to what we have read in our Newton's first law of motion, every body continued to be in the state of rest or in the state of uniform motion. Uniform motion matlab constant velocity until and unless an external unbalanced force act on it. Doesn't mean that if a body is at rest, no force will be acting on the body. Once again, if a body is at rest, does it mean that no force at all can act on the body? That is a simple wrong statement. Let's understand this first statement, Newton's first law of motion statement. Body at rest. I'm applying a 10 Newton force on the body. This is the only force that is acting on this body. Kya ho jayega? Yes, the body will start moving, right? Now, I'm applying a 10 Newton force in the opposite direction. Now, you know that the forces are acting on the body. But will the body be moving in this particular case if it was initially at rest? Will not. Q, because if you calculate the net force acting on the body, 10 plus minus 10, these two forces will cancel off and the total force is becoming 0 here, which means the force can act on the body though the body is at rest, right? And if you want the body to stay in the state of rest itself, the body should be cancelling off. Sorry, the forces should be cancelling off each other. So what we can understand from here, the state of motion, which means whether the body is at rest or whether the body is in motion, does not depend upon whether the force is present or not. It totally depends upon what is the net force acting on the body, right? If there is a net force acting on the body, like in this case, I'm applying 10 Newton towards, right? 8 Newton. Forces are acting and the net force is also there. What is the net force acting? 10 plus 8 is in the opposite direction. How much is it? 2 Newton. A net force is acting on the body. In this case, the body moves. Here, the forces are acting on the body, but still the body is at rest because the net force acting on the body is 0. So, once again, the motion of the body does not depend upon whether the force is present or not. It does not depend upon the individual forces acting on the body. It totally depends upon the net force acting on the body. If net force is 0, it will continue to be in that state itself. If there is a net force acting, then the body will be start moving. One more thing. If the net force acting on the body is equal to 0, we call this condition as balanced force. Matlab, forces are balanced. And for the body to make a motion, right, or in order to produce a change in velocity, or in order to have a change in state of motion, there should be a net force. And if there is a net force acting on the body, we call that force as forces which are not balanced or unbalanced force. Very important, keep this in mind. So these are the things that you should be taking from this first law of motion. ठीक है, कोई गड़बड़ नहीं, आगे बढ़ेगा. Inertia. Should I have to explain? 3 inertia is there, right? Or what is the general definition of inertia? The inability of a body to change from its state of rest or state of uniform motion is called as inertia, right? Which means if a body is at rest, if I'm at rest like this, can I move by myself? No, someone has to push me, right? Or I have to use the frictional force from the ground and I have to push against the frictional force which is existing in the ground and make myself move, which means some external force should be acting on the body, else I'll be continuing to be in the state of rest itself. Understood? Now, inertia is actually divided into 3. Inertia of rest, inertia of motion and inertia of direction. Inertia of rest matlab, inertia of rest, the inability of a body to change from its state of rest. Let's say bus, okay? Bus was initially at rest, so the person standing inside this particular bus will also be at rest. You know that for a body to start moving or to change from its state of rest, force has to be applied. If it is not applied, it will be continuing in the state of rest. Starts to move, and what will also be starting to move? Yes, the feet of our person or the feet of the person which is directly connected to the bus will also start moving. So if all these things move, what will be the position of the person? What will be the position? Bus moves, the below part moves, which means his foot will be moving and the person will be like this, because the downward part has gone like this, and what will happen? Yes, we will tend to fall backward. It is not because the upper body has gone backward, it is simply because the downward body has gone forward. So don't have a misconcept in this, and this is because of the inertia of rest. Matlab, we are not applying any force on the upper part of the body, so upper part of the body will be continuing to be in the state of rest itself. Note it down. Inertia of rest, IOR. Shall I explain inertia of motion with the same figure? Bus, okay, person, all of them were moving with a velocity of v, which means bus, upper body, bottom body, all were moving ऐसे अच्छे से जा रहा था. Suddenly this driver saw a dog crossing, he made a sudden break. What happens? This person or the bus will be stopped, velocity becomes 0, and the feet of the person will also be 0. What about the upper body? Upper body is not getting any direct force on it, so what will happen? The upper body will continue to move with the same velocity. So what happens? Yes, we tend to fall forward. Bus. समझ में आ रहा है? So this is inertia of motion. One more thing, last thing, inertia of direction. Is it done? ये तो हो गया है ना? कोई डाउट नहीं, कुछ कोई गड़बड़ नहीं है, सब बढ़िया. ठीक है, देख ले. अरे ये तो इधर गया. Okay, the very last thing, inertia of direction. मतलब same bus was moving forward, person was moving forward, the feet of the person was also moving forward, ऐसे. Now let's say the direction of the bus is being changed now. Now the bus started to move in this direction. Suddenly it took a turn towards left, let's say. Now this is the direction of its motion, right? And what happens? The feet will also start moving in that particular direction. So if you can see this, can you see this? So the bus will go, the feet will also go in that direction, but the upper body will be continuing to move in the same straight line direction. I know the drawing is not proper, but if you look, the downward part will be moving towards left and the upper body will be moving straight. But it feels to us that we are going to fall towards right when the bus is taking a turn towards left. Reason why not the upper body is not able to make a change in direction? Because no forces are given to the upper body. I know that many of you might be thinking, sir, even for changing the direction of a body, we need to apply a force. We are talking about velocity. Force is a vector, velocity which you are talking about is also a vector. And for changing vector, it is not only the change of magnitude, even for changing the direction of velocity itself is called as change of velocity. समझ में नहीं आया? देख ले. A body which was moving towards the right, 5 meters per second towards the right. Body was moving like this. Now, to make this body move towards north with the same speed of 5 meters per second, do you think should I be applying a force? Obviously. You can check that according to our example, the speed is remaining the same, which means the magnitude of velocity is the same, but even for changing the direction, we need to apply a force because velocity is a vector, it contains magnitude and direction. Even for changing the direction, it means changing the entire vector itself or changing the entire physical quantity. समझ में आ गया? हाँ, ठीक है, बढ़िया. Is it clear, everyone? हेलो हेलो सौम्या, हेलो एनी. तो कोई डाउट है? किसी को कोई डाउट है तो बता. कोई डाउट है तो बता, नहीं तो we'll start our very first mentee. We'll be having mentees in between बस. Perfect, clear. Okay, very good. Alarm clear आई. Nyara, Sana. Okay. So, shall we start with the mentee? How many of you are ready to do mentees? Code. Okay. So everyone is asking, sir, code क्या है? तो code तो हम जा रहे हैं. So पता नहीं, will it be going back to the discard? No worries. Okay, here we are. Okay. So everyone, so we have 10 mentee questions today, and we'll be doing the mentee questions in between. Okay, which means while we go, we'll be dealing with some of the questions. So you can do it all those questions as mentee. Very first question of today's class. So the code is 50651291. I'll write it down once here. 50651291. जल्दी से जल्दी फटाफट everyone join कर ले. And do let me know that whether how many of you have joined. जल्दी बता. अरे यार फोन तो, हाँ फोन ऐसे है. अरे यार फोन तो क्यों ऐसा हो गया. हाँ अब ठीक हो गया. How many of you have joined? I can't see anyone. I think I have to. Okay, so I can see some 8 students. Where are the others? Jaldi, 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 jaldi. I'll be starting the mentee right now within some time. Let's say in 5-10 seconds. Join. Those who have joined, please let me know what are your simple, what are your signs. We can see a magic hat, doggy doggy, kela hai, some angel, fish, honeybee, dinosaur. Then what we have? Diamond. How to join? You have to go to www.mentee.com. Okay, and the code that you have to use is 50651291. Jaldi, fatafat. Who is ship? It's Annie King. So you are the ship. Ishita is bee. Sana is ring. Pal, I am banana. Okay, theek hai. Crocodile. So I can see many of you. So I think it's time for us to start. Shall we? Last 5 seconds for you all to join. 5, 4, 3, 2, 1. ठीक है? Okay, so we're gonna start. The very first question. देख ले. A body weight W1 is suspended from the ceiling of a room through a chain of W2. The ceiling pull the chain by a force. Very simple, chotu sa problem, which everyone can answer. Those who are not able to join Mendy, no worries. Right, we'll be going back to our session after this quiz. Everyone has voted. Very good. Very good. It's W1 plus W2, and how many of my various gave the answer? 8. Badhiya baat hai. Let's see who all are those 8 students. And Paggi, I have no idea who that person is, Paggi. And Paggi is the person who gave me the fastest answer. Then Sana we have. Pal, Sanjana, Ameer sir ki warrior. Good, Sanjana. Kunal, Myara, Annie, Archie. Okay, so these are the 8 people who gave me the correct answer. Okay, so we'll proceed back. And congrats to all those who got correct answers. And let's see how this question can be done. Very simple actually. अरे यार ये कहाँ गया? हाँ इधर है भाई. So here we have our ceiling. Okay, from the ceiling a chain is there, and at the bottom a block is also hanging from the chain, and the weight of this, weight means the gravitational force, is W1. In which direction? Downward direction. And the weight of this entire chain, mass is this chain is having a mass, and the weight of this chain is W2. So can you tell me what will be the net force experienced by this particular end of the ceiling? W1 and W2, right? The sum of W1 and W2 will be the net force acting in the downward direction. Everyone can understand that, right? Obviously. So the net downward force acting on the ceiling is W1 plus W2. If you want to keep a point at rest itself, which means if the body is at rest, and if you want to keep the body at rest itself continuously, what is the condition I told you? Yes, the net force acting on the body should be 0. So in order to cancel this W1 plus W2, a force should be given by ceiling, let's say Fc. In which direction? Opposite direction. And what should be its value? W1 plus W2 itself. Why? So that the net force acting on this particular point will be cancelled, and this point will be continuing to be in the state of rest. Bas simple सा छोटू सा problem. Okay, कोई गड़बड़ नहीं है ना? Simple, simple, बढ़िया simple. So which is our option? हमारा option है option C. गड़बड़? नहीं गड़बड़, कोई गड़बड़ नहीं सर, बिल्कुल आपको जा सकता है. Okay, now we are slowly entering to the toughest part of this particular chapter. Now we are entering to the part of momentum. Okay, so what this momentum is, because it is based on this momentum we will be explaining Newton's second law of motion. Tell me, what is momentum? I know that momentum is a vector quantity, and everyone might be yelling out, momentum is sir, mass into velocity, isn't it? And what is the direction of momentum? Direction of momentum is same as the direction of velocity, because mass is a scalar quantity and velocity is a vector. We all know this, but if someone asks you to give you a small introduction, or let's say a small idea or definition about momentum, I'll tell you. It's simple, right? The momentum is actually the total quantity of motion. Okay, so the momentum is actually defined as the quantity of motion. What it is? It is actually the quantity of motion. You might be knowing the motion is totally dependent upon velocity, but it is hard to realize the quantity of motion is also dependent upon mass. I'll give you a small example. Let's say I have a body of mass m which is moving down with velocity v. Okay, and I have a huge ball, let's say its mass is 3m, moving down with the same velocity v. Holding which ball will be giving a huge impact on our hand, whether it's a chotu ball or the larger ball? There is no point to think itself. It is the larger ball when you hold, even though both are moving with the same velocity, the impact produced will be more for this larger mass. Matlab, more is the impact on your hand, more is the quantity of motion. Matlab, the momentum, which is quantity of motion, also depend upon mass. Okay, not just the velocity. That's why we have the equation for momentum as mass into velocity. Direction super duper duper ka upar bhi important hai, keep it in mind. Okay, done. So yes, proceeding further. Yes, ab very simple. Okay, ek aur this will be the next what our next mentee. After this mentee, we'll be having the next mentee after very long time. Tell me. Jaldi, jaldi, jaldi. Shall we do the Menti? Menti kar sakta hai? Those who want to read the question can read. A ball of mass 600 grams strikes a wall with a velocity of 5 meter per second at an angle of 30° with the wall and rebounds with the same speed at the same angle with the wall. The change in the momentum. First, I'll explain how this question is here, then we'll be proceeding. देख ले. Here we have our wall. Okay. A ball is coming by making an angle of 30° with the wall. And what is its mass? 600, and its velocity is equal to 5. So momentum is equal to, mass is 0.6. Why 0.6? In kilograms. This is in grams, so SI unit is kilogram. This is 3, which is the initial momentum is equal to 3 in this particular direction, right? And what is said in the question? It is said that while it collides with the wall, it rebounds, right? And it rebounds by making the same angle with the wall and with the same momentum of 3, which means the magnitude of momentum incoming and outgoing is the same, but it is clearly visible that the direction is totally different, right? So the question is, what is the change in momentum? How many of you can find this out? How many of you can find this out? Jaldi se fatafat. I'll be going back and we'll be opening the Menti part. Okay. Shall we start? Who haven't joined Menti, jaldi join kar sakta hai so that you can answer for this second question. And the code for joining Menti is 50651291. Jaldi fatafat. How many of you have joined? Bol de. Bol do na zara. The code, as you can see, it is 50651291. 50651291. I'll wait for 10 more seconds. Those who want to join, jaldi se join kar sakta hai. 8. This is 8, right? No, 7 it is. Now 8 ho gaya. 5, 3, 2, 1. I hope you all know how to join Menti. Go to www.menti.com and the code is 50651291. ठीक है. Let me start. Same question is here. And you still have 1 minute to answer. In the meanwhile, I'll just sit down for a small time. मैं तो इधर ही हूँ, ठीक है? I hope you all can see my head. जल्दी से start working out and give me the answer. I hope you all can see the code is on the top. There. 50651291. Very good. Simply amazing. बढ़िया बात है. Very good. 13 students got it correct. So seems like whoever is here is to learn this particular topic of laws of motion. I'm really happy. सच में. अरे बाप रे, 13 students got the correct answer. इतना अच्छा था मेरा various. Seems like your revision is also going very good. And Pagi, very good, Pagi. Still Pagi on the top. Sana is second with a chotuza point, and Sana was the person who gave me the fastest answer. Then we have Pal, Kunal, Miara, Annie, Archie, Tushar, Rapper, Dropper, Shire. Arey baap re. ठीक है, and he was also the fastest. So two fastest people are there, Sophia and Future IITN. Okay, Honeybee is Future IITN. ठीक है, बढ़िया बात है, very good. So shall we see how this question can be done? देख ले, it's not a big deal. आजा भाई. हाँ, इधर आ गया. ठीक है. So we already know this is our wall. वो तो ठीक है सर, आपका पेन काम नहीं कर रहा है. अरे येलो क्यों नहीं आ रहा है? और white also we can use, है ना? Okay. So let's say this is the wall. An incoming ball, by making an angle of 30, rebounds by making the same angle. Mass is 600 grams, velocity is 5. So momentum हो गया, mass is 0.6 into velocity is 5, so this is 3. So momentum incoming is 3 and momentum outgoing is also 3. These are the things given. Question is to find out the change in momentum. For finding change in momentum, you should be knowing the momentum completely. Matlab, not just the magnitude, its direction is also important. So shall I express this momentum in terms of x-axis and y-axis? Everyone dekh le. This is the initial direction of momentum. So I'm just extrapolating and drawing here the same direction of momentum. This is 30, ye 30 ho jayega with 3. Shall I take the components of this 3? Right, this is 30, this is away component, this is a 3 sine 30, and this component will be 3 cos 30, right? So now I can write the initial momentum proudly, P initial. It has two components, 3 sine 30. Sine 30 is 1 by 2. So 3 sine 30 is 3 by 2. Which direction? I cap. है ना? Then 3 cos 30, root 3 by 2. So this is through root 3 by 2. Which direction? J cap. Negative. हो गया. Initial momentum तो हो गया. Final momentum देख ले. Next color. This is 3. Let me take two components. One is downward components. This is 3 cos 30 downward, and this component is 3 sine 30 away component. I think I don't need to explain regarding the resolution of the vectors. Final momentum 3 sine 30. Which direction? Negative I. So 3 by 2 negative I cap minus 3 by 2 I cap. Then 3 cos 30. Cos 30 is root 3 by 2 J cap downward. Those who have written till here, finding out is not a big deal at all. P final minus P initial. Minus 3 by 2 minus 3 by 2 P final minus, so minus 3 by 2. How much it is? Minus 6 by 2 I cap. Then minus minus cancel हो जाएगा. So ये हो गया minus 3 I cap. मतलब the actual change in momentum is minus 3 I cap, and if you look into the magnitude of change in momentum, it's 3. सबको समझ में आ गया अच्छे से? हाँ. So all these are very important. देख ले. So we have assigned the components and the concepts of vectors. Super important. Anyone is having trouble with vectors, please do learn about vectors, because without vectors you can't learn this chapter. Okay. ठीक है. So what is waiting for us? Array, second law of motion. Again, if I ask you what is Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the force acting, and it acts in the direction of the force. This is the simple what's it, the definition you will be giving. How will you write the same? What is being said is the force is directly proportional to dp, means a small change in momentum to small change in time. This is what is expressed in the Newton's second law of motion, but understanding this concept is very important. Okay. So देखले, how can we explain this concept of F is directly proportional to dp by dt? Everyone. A ball which is coming downward. Let's say it is having a mass of 3 kilogram and its velocity is equal to 1. So what is its momentum? 3 into 1 downwards minus 3. Okay. So the downward momentum is there. So this is a cricket game. You are catching. So आपका hand है. I know that it doesn't even look like hand in any angle. So that's why I have written. It's a hand. It looks like a tuning fork, है ना? Anyway, so we are holding it, right? Once you catch the ball, what will be the final momentum? 0, because once you hold, velocity becomes 0, final momentum becomes 0. Tell me, what's the change in momentum? Delta P kitna hai? We are trying to understand this concept. So just listen to this example. What is change in momentum? 0 minus -3. है ना? 3. First case. Another case. Now I am having, instead of 3 kilogram ball, I have 6 kilogram ball and the velocity is 2. What is the initial momentum? 6 2s are 12. Downward. Same case. Here also you are playing cricket. You are holding it. Once you catch this ball, क्या हो जाएगा? Final momentum becomes 0. है ना? Change in momentum. How much is it? 0 minus -12. It is +12. Now just tell me, in which case, whether you hold a 3 kilogram ball or a 6 kilogram ball with twice the velocity, your hand will be experiencing a larger impact. The one which is having a larger mass and larger velocity, or the one which is having a larger change in momentum. Matlab, the impact that your hand experiences is directly proportional to the change in momentum. So that's why the impact is called as force. So force is directly proportional to the change in momentum. And obviously the last statement is, we'll come to this time part, and the last statement is, the change in momentum happens in the direction of the force axis, right? What is the change in momentum sign? Plus. Plus matlab upar. Change in momentum is upar, right? And according to what is explained in Newton's second law of motion, whatever is the direction of change in momentum, that should be itself the direction of force experience. 6 kilogram moving with 2 is becoming 0, and its change in momentum is this +12. And what is the direction of force it experiences? When you hold the ball will be giving a force on your hand in the downward. Third law of motion, your hand is giving a force in the upward direction on the ball. है ना नहीं? देख ले अभी. Are the direction the same? Are the direction of the change in momentum and the force acting on the body the same? बिल्कुल, it is completely, and super का duper का ऊपर का भी same है. So understood the first part of the statement, and the very last part. Now you'll understand the second part, which means how force and time is actually related. देख ले. This case, which means the ball moving with velocity of mass 3 kilogram you are holding, so final momentum becomes 0, change in momentum is 3. Same case, mass is same, velocity is same, which means the initial momentum is -3. But in this case, you might have seen, or those who have played cricket might be knowing, you won't be holding that ball or catching the ball with your hand still. You will be withdrawing the hand like this, right? Before stopping the ball, you will be withdrawing the hand along with the ball. Why it is being done? It is done because your hand will be experiencing a lesser force. है या नहीं? देख ले. Coming back to our example, it was having an initial momentum, but this time you are withdrawing the hand backwards, and finally you are making the momentum as 0. Obviously the change in momentum here, isn't it same? 0 minus -3, it's the same, but still here our hand will be experiencing a lesser force. Though the change in momentum is the same, our hand is experiencing a lesser force, in which case while we withdraw our hand. Tell me, while we withdrawing our hand, what is increasing? The time required for the change in momentum, isn't it increasing? And when the time has increased, what you have seen? The force has decreased. Matlab, the force and the time is inversely proportional. Ye, how many of you have understood? Very beautiful and very required concept. समझ में आ गया सबको अच्छे से? हाँ सर, आप हिंदी में पढ़ाओ प्लीज. सो पीयूष शर्मा पहले मैं ये बोलेगा कि आप मुझे पहले हिंदी सिखाओ. मुझे बिल्कुल हिंदी नहीं पता है, मनसला क्लियर आने देवेगा, बढ़िया बात है। हाँ, थोड़ी थोड़ी हिंदी में बात मुझे भी कर सकता हूँ, थोड़ी थोड़ी बस उतना ही है। रितु सिंह, बेस्ट फिजिक्स टीचर आई हैव सीन। अरे बाप रे, इतना बड़ी। ठीक है, थैंक यू सो मच रितु। हाँ, थोड़ी थोड़ी हिंदी में बोलेगा, पक्का पक्का। ओके, सो ये तो समझ में आ गया अच्छे से, अच्छे से समझ में आ गया सबको, that the force is directly proportional to the rate of change in momentum, that is dp by dt. हाँ, okay. Now force is directly proportional to dp by dt. How will you convert this into an equation? By multiplying it with a constant, and this constant was found to be having a value of 1. So the final equation for force is d by dt of p, or F is equal to d by dt of momentum is mass into velocity, right? Which means inside differentiation you have mass and velocity. Tell me, in the usual case, when you apply a force on the body, what is going to change? A body of mass m. If you apply a force, will the mass of the body be changing? No. In the usual case, what you will be seeing is the velocity will be changing, or you can see that the velocity in that direction is changing, है ना? Which means mass will be a constant in most of the cases where you apply a force and accelerate the body. So mass can come outside. So F is equal to m, because m constant has no meaning inside differentiation. M comes outside. ये हो गया dv by dt. So the equation for force is m into dv by dt. बोल दो ना जरा, ओके, थोड़ी हिंदी बोल दिया, ठीक है। dv by dt क्या है? What is dv by dt? Change in velocity by time, rate of change in velocity. जिसको नहीं पता है आप अरे यार हिंदी पूरा नहीं मिल रहा है, जिसको नहीं पता है आप अरे यार छोड़ दे बस so F vector is equal to mass into acceleration vector, very important, or let's say the entire chapter is revolving around this particular equation. ठीक है, okay. Now let me tell you one more equation for force which is very important. सुन ले सब, okay. One more important equation is there. So I hope everybody have noted this down. Noted? बिल्कुल अच्छे से. I'll wait. If anyone want me to wait, I can wait. Someone is asking आप कहाँ से हो? So मैं तो केरला से. Okay, ठीक है. Let me tell you, the equation for force is not only for mass into acceleration. There is one more equation for force. I'll explain you. देख ले. How many of you have went to airport? Or at least how many of you have seen a movie with the airport? And when they go to take a baggage, you might have seen this what we say for this. अरे इसका नाम क्या था? Let's say roller. Okay, which means on a sheet, okay, on a sheet the bag will be inserted and the bag will be moving. मैं तो उसका नाम तो भूल गया, कैसे भूल गया पता नहीं, है ना? So this roller will be taking this particular bag through Odyssey, and you might have seen, or those who have observed this, right, will be knowing that this will be moving with a constant value of velocity. Now to make this roller move, or to make this body move, right, we don't have to apply a force in this case because the mass is a constant. Let's say you have two bags of mass and momentum and it is moving with a constant value of velocity. ठीक है, देख ले. Now to this particular roller which is moving, I'm adding a third mass. Tell me what will happen. What will happen once you add a third mass to this moving system? Yes, the velocity will decrease obviously, है ना, because it was moving with a constant value of velocity with 2m. Now extra mass is being added up. So what will happen? The velocity will decrease. So to make this roller move with a constant value of velocity, extra mass is added, velocity will decrease. So to make this roller move with a constant value of velocity, what has to be provided? A force has to be provided. So here the force is being provided to make a constant value of velocity. In which case? In the case of changing mass. Here the mass is changing. So equation of force will be how much? d by dt of momentum is mass into velocity. Here who is constant? Velocity is constant. So the equation here for force is equal to, अरे v जैसा दिखता है ना, v into dm by dt. Very important it is. So the force is equal to v into dm by dt. अरे मुझे हिंदी नहीं आता है, मैं तो कैसे पढ़ाऊंगा आपको हिंदी पे, है ना? So जल्दी बोल दे, ये तो हो गया, समझ में आ गया सबको? सबको समझ में आ गया. So the equation for force in this case is v into dm by dt. Okay, so if everything is clear, हिंदी तो मैं बिल्कुल सीख रहा हूँ मैं, ठीक है, मैं तो थोड़ा थोड़ा सीख रहा हूँ बिल्कुल. श्रेया यस, आर्ची यस, आई एम फ्रॉम केरला, ठीक है. सो कोई डाउट है तो पूछ ले. भूमिका, सुजल, वंश, शुभम, आर्ची. मेंटी विल हैपन इन बिटवीन बस. बिल्कुल नहीं सना, नॉट एट ऑल. I'll be that Malu teacher all the time. Okay. So someone is asking, sir, Menti start karo. Menti will happen in between. Okay, this is not an entire Menti session, right? We'll be doing Mentis in between. So ठीक है. Newton's third law of motion. Everyone knows. Every action has an equal and opposite reaction. बस. And what are actions and reactions? ये action and reaction क्या है? Is it like हमको एक थप्पड़ मिल गया वो तो एक्शन है, एंड वील बी गिविंग इट बैक वो तो दूसरा रिएक्शन है? ऐसा कुछ नहीं. एक्शन एंड रिएक्शंस आर डिफरेंट वर्ड्स फॉर व्हाट? फोर्सेस. ओके, टू नेम्स गिवन फॉर फोर्सेस बस. I hope I don't need to even give you the example because everyone knows. Let's say a bird fly. How the bird is able to move upward? Someone has to give a force upward. Who is giving a force upward? Directly. When the bird is flying with its wings, it is giving a force on the air in the downward direction. So on the air, with the help of the wings, the bird is giving a force in the downward direction. And according to Newton's third law of motion, we know that if a force is given on air in the downward direction, right, a same amount of force will be given by air on this bird in the upward direction. That's Newton's third law of motion. देख ले how this person is able to jump out of this boat. कैसे कर रहा है? He is pushing this particular, he is pushing away this particular boat in the backward direction. So every action has an equal and opposite reaction, right? So the boat will be pushing the person in the forward direction. Person is pushing boat backward and the boat will be pushing the man in the forward direction with an equal amount of force. This is Newton's third law of motion. सबको पता है ना? Every action has an equal and opposite reaction. How many of you can tell me, though there is equal and opposite forces, why the forces are not getting cancelled? Why the bodies are able to move? Very simple सा बात है. Because these forces, equal and opposite forces, are not acting on the same body. If equal and opposite force act on the same body, they get cancelled, right? But here, on the boat, if you look, only one force is acting, which is this F. Okay, and on this man, only one force is acting, which is F. Okay, so these are some simple doubts from where Newton's third law of motion you can have. कोई गड़बड़ नहीं है ना? कोई गड़बड़ नहीं, सब बढ़िया. So ठीक है. This is very important because everyone will be asking you what is the thrust force, what is the force with which the rocket is moving up, or how the rocket is able to move up. हमारा rocket भैया, or we'll take a separate. I'll draw separately for you. अच्छा वाला rocket. Okay, you know that Ameer भैया अच्छा वाला draw करता है ना? He's a good drawer. So ये हमारा rocket. देख ले. सुंदर सा बनाया हुआ white rocket, and it has a nozzle at its bottom. I know that what you all are thinking. Sir, the crackers we used to get from the cracker shop, firecracker shop, looks beautiful than this. अरे यार मजाक मत उड़ा अमीर भैया को. अरे देख ले. So we have this rocket. ठीक है. Inside the rocket we have our fuel. Let's say the fuel is having a mass of m. So the reason why this rocket is able to move up is this fuel will start burning. Fuel will start burning. So this fuel will be converted into its gaseous state and it will be given out with a high pressure. And it is made sure that this particular air coming out from this nozzle is coming with a constant velocity of u. And what this air coming out through this nozzle will do? Yes, you have the air beneath. Air will be pushed with a force of F by this gaseous molecules in the downward direction. And air को क्या हो जाएगा? गुस्सा आ जाएगा, है ना? Air is like मुझे क्यों push कर रहा है भाई तू? So air will be giving an equal amount of force on this rocket in the upward direction. And it is by using this particular force rocket ऐसे ऊपर उठेगा. ठीक है? Tell me. Here also, what will be the equation for force? Basic equation for force is d by dt of mass into velocity. I told you this particular gas which is coming out, which is the reason for the production of force here, is coming out with a constant value of velocity, which means u is the velocity, u is the velocity of gas with respect to this rocket. Okay, with respect to the rocket, okay, which means if you are sitting here on the rocket, okay, आप ऐसे sit कर रहे हैं रॉकेट के ऊपर एंड रॉकेट ऐसे मूव कर रहा है ना, कितना अच्छा सीनरी मिल जाएगा आपको. उसके बाद आपका सीनरी देखने के लिए बहुत सारे लोग भी आ जाएगा. देख ले. So you are sitting on this rocket and once you sit on this rocket and observe that this gas which is coming out of the nozzle will be coming out with a constant velocity of u. So tell me, what is the changing factor? Obviously it's not the velocity which is changing, which is the reason for production of force. देख ले, when the mass, which means when the fuel burns, mass will decrease. Array, the reason for the production of this particular gas is the burning of the gas. So when the gas burns, its mass decreases. So what is the changing factor inside mass into velocity? It is mass. So the equation is velocity will come outside, dm by dt. So this force we call it as thrust force. Okay, thrust wala force we call it, the name given to the force applied on this rocket is thrust force. It is equal to u dm by dt. And you might be seeing this with a negative sign. ये negative sign क्यों sir? अमीर भैया बोल दे, ये negative sign क्यों? अरे dm मतलब change in mass, right? Mass is decreasing. So if you find change in mass between final mass minus initial mass, won't it be negative? है ना? Obviously. So dm by dt will be negative. In order to cancel that negative sign, we are adding an extra negative. ठीक है? So this negative sign from dm will be cancelled by this extra negative sign we add and we get the equation for the thrust force. समझ में आ गया? समझ में आ गया सबको? श्रेया, भूमिका, तुषार, तुषार रैपर. चलो सर हमारी वेदांत की. ठीक है ठीक है. कोई डाउट है तो म्यारा, वंश, हुमैरा, फारूक, हैकर, श्रेया कुमारी, रितमा, निर्मला, प्रीति. क्लियर? ओके, वेरी गुड वेरी गुड वेरी गुड. बढ़िया बात है, बढ़िया बात है. सो आई कैन सी यस फ्रॉम एवरीवन. ओके, नेक्स्ट कॉन्सेप्ट पे जा रहे हैं हम. Conservation of momentum, another super beautiful concept. In the meanwhile, I'll also sit a bit and I'll be explaining. Okay, shall we explain? Bhumika, Sujal, Avocado, Harsh. देश में कोरोना का कहर है, सर की टीचिंग में जहर है. इसका मतलब क्या है? I have no idea. Anyway, thank you so much. If it's good, thank you so much. If it's bad also, ठीक है, thank you so much. बिल्कुल बढ़िया है ना? I have no idea. Now, let's have understanding about the conservation of momentum. Conservation of momentum का मतलब ये है कि right when the momentum is going to be a constant, or what is the condition for keeping the momentum of a system as a constant. We know that, देख ले, net force acting on the body is equal to dp by dt, है ना? The net force acting on the body is equal to dp by dt. And let's say on a body, the net force acting on the body equal to 0. What did I say? Let's say in a case if the net force acting on the body is equal to 0. So which side will be 0 in this equation? The right hand side of the equation will be equal to 0. And this will be equal to dp by dt. मतलब क्या होता है? dp will be equal to 0. dp मतलब क्या है? Change in momentum. I hope you all know what you mean by d. d corresponds to change. d मतलब छोटू change. That's what this small d corresponds to. Those who don't know, please note it down. d मतलब small change, right? So if the net external force acting on the body is equal to 0, the change in momentum is equal to 0. How will you write change? P2 minus P1. This will be equal to 0. Matlab, if you write P1 to the right hand side, P2 will be equal to P1. Matlab, understood? If the net force acting on a system is 0, the momentum of the body will be a constant always. If there is a net force acting on the body, if the net external force acting on the body, make sure you look into this particular word all the time, external force. If the net external force acting on the body is equal to 0, the momentum of the body or the system will always be remaining as a constant. बड़ा बिल्कुल बड़ा important concept है. Okay. Now, I'll tell you one simple thing based on this particular concept. How many of you have shot a gun? How many of you? And those who have shot a gun, at least those who have seen the rifle shooting in Olympics game, or at least those who have seen some movies. But movies pe, even when you shoot a small gun also, tish, kish, 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 that sound used to come. Hai. When I used to see all those old movies, this sound used to come. When someone shoots, like tish, kish, kish. Arey yaar, those good old days. Anyway, coming back. How many of you know that when you shoot a gun, right, the gun will be having a tendency to move backward? How many of you know that? Which means the gun will be, we call it as recoiling. The gun will be recoiling when you shoot a bullet from that gun. Let's understand what is the reason and how can we find out the velocity with which the gun will be moving backward. Shall we? देख ले हमारा अच्छा वाला gun, okay, one of the finest gun available in our country, and this is our bullet. Okay, so this is our gun and bullet. Before the shot was being fired, can you tell me what would be the initial momentum of this entire system? Which means for the gun and the bullet, what is the initial momentum? बोल दे, बोल दो ना जरा. हाँ, वो तो zero है because velocity of both is zero. But the moment you shoot that particular bullet from the gun, how will you shoot? During the time of shooting, what is happening? During the time of shooting, देख ले, a force is being applied by the gun on the bullet. Can you all see? A force is being applied on the bullet by the gun in the forward direction. Third law of motion. If a force is applied on the bullet by the gun in the forward direction, an equal amount of force will be provided by the bullet on the gun in the backward direction. So it is because of this particular force the gun will be moving in the backward direction. Understood the reason for the recoiling of the gun? Okay, now you have understood till here. Tell me, what is the net external force acting on the body? on this gun bullet system, what is the net external force acting on the body? Can you see anyone providing a force here? It is zero. No one is providing a force here. So the net external force acting on this entire gun and mass system is zero. Now you'll be asking, sir, ये F and F आपको देख सकता नहीं है कि ये दो forces इधर है? अरे these are internal forces. Internal forces acting within the system of this gun and the bullet. And if you even calculate the total internal force acting, how much? Internal forces are getting cancelled. Internal forces can't do anything to the body. समझ में आ गया? Or even if you look, sir, तो forces act तो कर रहे हैं. Why you not counting? अरे देख ली, even if it is acting, forces will get cancelled. Internal forces will always get cancelled. That's the reason why the motion of a body is only dependent upon external forces, because internal forces will get cancelled each other, because it will be always in pair because of Newton's third law of motion. ठीक है. Net force is zero. So what can I write? Initial momentum of the bullet and mass and the final momentum will be equal, है ना? Which means the initial momentum is equal to zero. मतलब final momentum of the system of gun and the bullet will also be zero. That's what it says. But before making a conclusion from here, let me ask you, or you will also be having the doubt, sir, ये final momentum बता sir, बता ये final momentum कैसे zero हो जाएगा? Because you can see the movement. अरे देख ले, after it is being shot, this bullet of small mass m will be moving forward with some capital velocity v. Because of this recoiling force, this gun with a large mass will also be moving with a small velocity v. We call it as recoiling velocity. But still, how it is possible for the final momentum of the body to be zero? We are not talking about the individual momentum. What is individual momentum of this? Mass into bigger velocity. What is the momentum of the gun? Larger mass of the gun into its smaller velocity but with negative. We are not talking about individual momentums. We are talking about the total momentum of the system. Individually they will be having momentum, because if you take the bullet alone, isn't there a force acting? Yes. So it will be having a momentum, obviously. But we are not talking about the individual momentum or the individual body. We are talking about the total bullet and the gun system. Its total momentum should be zero. How will you calculate the total final momentum of the gun and the bullet? That is m into v plus this m into v with a negative sign. Now yes, now you can understand why they are getting cancelled and becoming as zero, because one is in forward and the other one is in the backward direction. Now you can find out any given velocity or unknown velocity. Let's say you want to find out this small v, mass of the bullet, velocity of the bullet, mass of the gun, velocity of the gun, so that you won't be having any confusion. How will it be? This goes to the left hand side. Mass of the gun, velocity of the gun. Mass of the bullet, velocity of the bullet. You want to find out the recoiling velocity of the gun, Vg. How much? Mass of the bullet, velocity of the bullet by mass of the gun. ठीक है सर, बस समझ में आ गया, अच्छे से समझ में आ गया. समझ में आ गया तो please note it down. The equation to find out the recoiling velocity of the gun. Very important, super का duper का important. Obviously, Vicky, you can watch it because we are doing from the basics. How many of you are here who is learning Newton's law of motion for the very first time? How many of you are here? जल्दी बोल दे. Clear? I hope you all have noted down. I'm going to rub this off. ठीक है? How many of you are learning this particular concept for the very first time? Jaldi. Kunal, now let me ask you, are you able to understand? Are you able to understand even though you are learning this particular concept for the very first time? Starting से revision lab start होगी. किससे बात कर रहा है तू आप? So I hope everyone is understanding, because everyone should be understanding, because we are going with the basics of this particular chapter. ठीक है. Going for the impulse. You know, hammering of a nail, है ना? Hammering of a nail, everyone knows. Then during the hammering of a nail, we are applying a large force on that nail for a very short interval of time, right? And the whole effect produced by that force, which is acting over that particular time interval of time, let's say, that is called as impulse. The effect of a large force producing over the interval of time which it acts is called as impulse. Let's say the force that is acting on is F, which means during the time of hammering a nail, the force applied is F, and the time duration which it acts is dt. The total effect produced by the force on that nail by the hammer will be equal to force into time. Understood? How much will be the total impulse? The total impulse is calculated as the total large force acting for this very short interval of time will be equal to the impulse, which is the large effect of the force acting over that short interval of time. That is called as impulse. Okay. And from here, by looking into the impulse, how many of you can derive a relationship between this impulse and the momentum? Impulse written with J. J is a symbol we use for impulse. It's a vector because impulse is equal to force into time. So whatever is the direction of the force, that itself is the direction of the impulse. ठीक है. Now, is there any method by which we can equate the impulse and momentum? There is. देख ले. Force is equal to dp by dt. याद है? Those who don't remember, अरे कौन कॉल कर रहा है मुझे इसी टाइम, है ना? सबको पता है. Now from here देख ले, dp is equal to f dt, है ना? f dt is equal to dp. So f dt क्या है? अरे what is this f dt? Impulse, and impulse is equal to dp. मतलब change in momentum है या नहीं? dp मतलब change in momentum. f dt is impulse, so impulse is equal to change in momentum. So j f dt can be written as delta p. मतलब the impulse is equal to force into time, or the change in momentum is also give or will be giving you the impulse, the large effect of the force produced for a short interval of time, which is impulse. And I think I don't need to tell you whether it is a vector. Obviously it's a vector. It acts in the direction of the force or in the direction of change in momentum, है ना? Unit force into time. Force is Newton, time is अरे मीटर क्यों लिखा मैं? कौन लिखता है सर? सर आप क्यों इतना केयरलेस हो गया? अरे माफ कर दो अमीर भैया को. So force into time. Force is Newton, time is seconds. So Newton second is the unit of impulse. Fine, clear? Okay, I think it's not a big deal to understand till here. Any doubts anyone is having, you can mark it in the, or let me know in the chat box. Yes, Humaira, it's Newton second. Very good. Okay, okay. Now done. Which means we are done with the introduction of this particular chapter, and now we are entering to the main body of this particular chapter. Everyone, those who haven't written all the notes till now, try writing down all the notes and doing the problem from now onwards, because this is very important. Everyone should be having a pen, book, and start writing, because what we are going to do now is so serious. Okay, which means important parts of this particular chapter we're going to write. Start. Mansi, Arpan, Sophia, Shubham, Sankamitra, Ridhima, Avishiga, everyone super ready. Noted. Okay. Sir, a question hai. So obviously, okay, we are going to do lot many questions. देख ले. What is free body diagram? Free body diagram मतलब representing all the forces acting on a body along with its direction so that we can find out the net force acting on our body and we can find out the acceleration. अरे सार क्या बोल दिया आपने, इतना बड़ा थियरी कौन बोलता है, कोई बात नहीं, देख ले, डोंट वेरी एट ऑल, है ना. Now, what is free body diagram, or how can you draw a free body diagram? What is the use of a free body diagram? देख ले. So, this is our ground. Okay. On the ground, we have a block of mass m, and on top of it, we are having a block of mass small m. The question is, you know that this block of mass m will be pushing this ground in the downward direction, right? And similarly, the small block mass m will also be pushing this capital block in the downward direction. The question is not that. Question is, draw the free body diagram of this smaller mass and bigger mass. When someone asks you to draw the free body diagram, take that mass or body from the system and draw it separately. You took it separately and you have drawn. It is, even it is okay, you can just express this mass or this body as a point also. That is also fine. Now, after this, after taking out the body, for expressing a free body diagram, mark down all the forces acting. Which are the forces acting? Tell me, one by one. Which are the forces acting? First force. On every body, a common force will be there. If it is on earth, its weight, which is mg, right? Is there any other force acting? Do you remember about the types of force we discussed? There we discussed about a force. Yes, it is the normal force. This block of mass m, the chotu block, will be pushing this larger block in which direction? In the downward direction, n, let's say. And third law of motion, this capital block or this large block will be pushing the small block with the same amount of force in the upward direction. So on this block of mass small m, along with its weight mg, one more force is there, n. So we have drawn the free body diagram along with the direction. Now, next question you all can have is, sir, why we need to the free body diagram? हमको क्या फायदा है? What is our use? If you can draw the free body diagram, we can find out the acceleration of the body, because we already know the net force acting on the body is equal to mass into acceleration. सबको पता है ना? सबको पता है. What is the net force? An upward force of n plus downward force of mg. To represent it as downward, minus mg. Why down? Minus mg is acting in the downward direction, is equal to mass into, what is acceleration? अरे is this body moving? बिल्कुल नहीं. तो acceleration तो zero है, हमको पता है. So what is it? We got the normal force in this case is equal to how much? Its weight, which is equal to mg. We just have proved this. Okay. Now, it might find it difficult, but later on you'll find or you'll think that अरे ये तो कितना easy part बोल रहा है sir. Okay. So those who know and those who know or those who think that it is easy, fine, because this is a basic. And those who are new to this, please practice, because practice can only make you better in this, because we will be doing more and more advanced level problems from here. Okay. Next part. Draw the free body diagram of capital M. First, draw all the forces which we already know. First is capital Mg downward, its weight. Then this normal force. This is the normal force given by the small block of mass m on this capital block in the downward direction. Then, is there any other force? Take one more force is there. This block of mass m, right, will be pushing the ground with some other normal force n dash, which we don't know what it is, right? And similarly, Newton's third law of motion, this ground will be pushing this block m in the upward direction with the same force. So there is an upward force of n dash. So these are the forces acting on this capital block of mass m. Apply. Net force is equal to mass into acceleration, right? Which are the forces acting? Upward there is only one force, that is n dash, upward, downward, minus n, one more minus mg equal to mass into acceleration. Is it moving? Is it moving? I can't bend more. Is it moving? No. So acceleration is 0. Right hand side is 0. So n dash हो गया n plus mg, है ना? Write it. N dash is equal to n, we can substitute. N कितना था? अरे small mg plus n dash is equal to m. अरे ये तो big mg था. Okay. So we got it. So if you draw the free body diagram of each and every body, we can find out the total forces acting on the body. We can find out the unknown forces, and we can also find out the acceleration if it is not given or if it is not known. So these are the uses of drawing a free body diagram. है ना? रेस्ट तो हाँ ठीक है, मैं तो अभी तो कोई बात नहीं, अभी तो चल रहा है, पता नहीं कब तक चलेगा. तो समझ में आ गया इधर तक सबको? If you have any doubt, let me know, please just let me know. मेरा अलार्म परफेक्ट आई? हुमैरा फारूक, यस यस मानसी, बिल्कुल बिल्कुल बिल्कुल. मेंटी कुणाल इज लाइक सर मेंटी चाहिए हमको. लेट्स सी. अरे आ गया कुणाल, जो आप बोल रहे थे आ गया, मेंटी आ गया. सो शैल वी डू द मेंटी? नीड नहीं दे दिया था, मैं तो इंजीनियरिंग स्टूडेंट है ना. So yes, here we go. So here we have our question. Let's read the question and then we'll be moving for Menti. Okay. A block of mass m is pulled on a smooth horizontal table by a string making an angle of theta with the horizontal. If the acceleration of the block is a, find the force applied by the string and by the table n on the block. There are two questions. A block of mass m, you are applying a force, or someone is pulling this block by making some angle theta. So if someone is pulling with the help of a string, tell me what is the force here. I told you I won't be explaining while I start doing the problem. Yes, the force will be tension force, right? The question is what is the tension force, and the second question is what is the normal force. If the body is moving towards right with an acceleration, the acceleration of the body, obviously it is not moving up, so it will be moving or it will be sliding along the horizontal surface with an acceleration a, tension is t, angle is theta, normal is also has to be found out, t also has to be found out in terms of angle a, and in our Menti you only have to mark the value of t. T का value सिर्फ करना है. Okay, so we are moving for Menti quiz. ओके हमारा मेंटी भैया कहाँ है? अरे मेंटी भैया आ गया. मेंटी मूव कर ले. ओके जल्दी से फटाफट ज्वाइन कर ले those who haven't joined Mendi to answer that question, the third question of today's session. जल्दी जल्दी जल्दी. So those who cannot see the Menti code, it is 50651291. जल्दी everyone. Okay, so everybody joined. शुरू करें. शुरू करें. हाँ, code is 50651291 है ना. Last 10 seconds for those people who haven't joined Mendi and those who want to join Mendi. In 5, 4, 3, 2, shall we start? Okay, yes, here we go with the third question. It started. Question is same. You don't have to give the value for normal. You have to give the value for tension force bus. Give the value for tension force bus. Done. अरे बाप रे, people are so fast here, है ना? अरे ये तो इसका अंदर चिपा गया. Last 14 seconds. जल्दी जल्दी फटाफट. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And time is up. And अरे very good बाप रे. 4 students, but what happened to others? क्या हो गया आप लोगों को? So anyway, let me see who are those 4 students who got the correct answer and who is leading the leaderboard. अरे वाह, this is so amazing. Miara on the top. Miara, बढ़िया बात है. Then we have Sana, good. पकी क्या हो गया आपको? आप इधर था ना? So Paki, Pal, Sofia, Kunal, Ani, Archie, Future IITian, तुषार रैपर ड्रॉपर शायर. ठीक है, अरे ये पता भी नहीं ड्रॉपर शायर. Anyway, so good, amazing, right? Keep it up. So I hope whoever have given the answer and others also have tried doing this particular problem and at least understood half of the concept. Okay, so let us understand it completely. देख ले. So as we already have discussed, this is a case, right? A tension force is acting because a person pulls this block of mass with the help of a string. So inside the string, a tension will be there. So directly on this mass, tension will be acting by making an angle of theta. Question is, what is this T? What is the value for normal force? कर ले, let's do it. अरे ये तो किधर गया? इधर रहता है, वो उधर रहता है. उधर रहता है, ये इधर रहता है. Okay. Now, first let us resolve all the forces acting. First force is this, T cos theta, right? This is T cos theta and this component of force is T sin theta, right? And marking other forces, there is a normal force in the upward direction as you can see upward, and there is a downward force of mg. Bus. These are the forces acting. And what is the only direction in which the particle is moving? In the x direction, right? Shall we start resolving the forces and find out the accelerations? We know that net force acting on the body is equal to mass into acceleration, and net force acting along the x direction is only responsible for the motion and the acceleration of the body in the x direction. Okay, force acting on the body in the x direction is responsible for producing acceleration in the x direction. Force acting in the y direction is responsible for producing acceleration in the y direction. I think I don't need to explain you that. Then what is the only force acting in the x direction? T cos theta is equal to mass. Acceleration is given in the question. अरे acceleration A तो given है ना? If the acceleration is A, it's ma. So t का value हमको इधर से ही मिल गया, ma cos theta. बस. Now those who want to find out the normal force, write down the equation in the y direction. Net force in the y direction is mass of the body, acceleration of the body in the y direction. What are the net forces? Upward t sin theta, है ना? Upward normal force minus downward mg. Is the particle moving in the vertical direction? No, it's not moving, right? The body is only moving horizontal. So acceleration in the y is 0. So right hand side is 0. So those who want to find out what n is, minus mg going to the right plus mg minus t sin theta mg minus t कितना है देख ले ma by cos theta sin theta. So if you want to combine and write mg minus ma tan theta, बस simple है ना, कोई गड़बड़ है तो बता. I don't think you have any issues. कोई है तो बता. If you have any issues in understanding the concepts. कुछ भी नहीं. कुछ भी नहीं. So I can't. I'm looking actually into the chat box. I'm not able to see any doubts. तो बिल्कुल I'm gonna think that सबको अच्छे से समझ तो आ गया. समझ तो आ गया तो मज़ा भी आ जाएगा. अगले क्वेश्चन कर ले. The next question is, in the arrangement shown in figure, the strings are light and inextensible, which means not extending. The surface over which the blocks are placed is smooth. Okay. Question, find the acceleration of each block, the tension in each string. So let me mark. The tension here is T1 and tension in this string is T2. Tension in this string is T2. Okay. You know that in a given string, the tension is going to be the same, right? And only if the strings are different, tension will be different. So here this is a common string, will be having tension T1. This is a tension T2. So this is a question. This is also another Menti कर सकता है. Let me ask you, are you all interested in doing the Menti? If you all are interested for doing the Menti, हम तो कर सकता है. नहीं तो we can do it as a normal question. आप ही बता दे जल्दी फटाफट. मेंटी करना है या नहीं मेंटी करना? जल्दी जल्दी जल्दी. लुकिंग फॉर एवरी वन ऑफ यू. You don't know how to join? That I'll tell you. Right, Sankamitra. नहीं करना. Some are like नहीं करना. Okay, so people are like sir हाँ मेंटी तो चाहिए. So ठीक है, मेंटी करेगा. Understood the question, right? Question तो समझ में आ गया. ठीक है, तो मेंटी पेज पे जाएगा. Okay, so many are telling sir we don't know how to join the Menti, right? How to join Menti? You just go to your browser, internet browser, and there you type www.menti.com. Type कर ले. Okay, typed everyone. Type करने के बाद they'll be asking you for a code, and the code is 50651291. ठीक है, your code apply कर ले, you will be inside the Menti. बस, I hope you all can do this. बस once you do this हो गया. बिल्कुल तो काम तो हो गया बस. I'll wait for next 10 more seconds, then I'll start the Menti. Last 8 seconds to join. Last 5, 4, 3, 2, 1. Here we go. Everyone start reading the question and try to get the answer. This force is 14 Newton, 1 kilogram, 2 kilogram, 4 kilogram. So if you think that the picture is Chotu. Those who think the picture is Chotu, now I hope you can see. Force is 14 Newton, masses are 1, 2 and 4. Last 20 seconds. जल्दी फटाफट everyone. जल्दी से उत्तर दे दे. 12, 11, 10, Okay, time is up. How many of you got it correct? Okay, 4 students. Answer is 2 meter per second square. T1 is 10 and T2 is 8 Newton, right? देखिएगा अब. What do we have here? Puggy was the fastest person and Puggy is on the top at last. Puggy, very good. Sophia is there, Miara is there, Sana is there, Pal, Kunal, it's Ani, Archie Mishra, Future IT and Thanish. Very good. बिल्कुल बिल्कुल बढ़िया. So let us go back and understand how to do it. देख ले. You know that whenever I apply a force of 40 Newton on this 1 kilogram, is a 1 kilogram going to move alone? Now, how is it going to move? The entire body will be moving as a single system. Right? The entire body will be moving as a single system. Right? And if you consider this entire body as a single system, what is the only external force acting on the system? It is a 14 Newton. How will you find the acceleration of all the 3 bodies which is moving with the same value of acceleration? This is equal to total force divided by total mass, because all are moving together. Force का value 14, total mass 4 plus 2 6 plus 1 7. ये हो गया 2 meter per second square. बस simple. Understood? बढ़िया, कोई गड़बड़ नहीं. Now the questions are how to find out this T1 and how to find out this T2. Tensions are internal forces. So you cannot take the system as one complete body for finding out tensions. You have to take the free body diagram of separate bodies. So for finding T1, मैं तो ले रहा है 1 kilogram body. Mark the forces. One is the force 14 and then a force towards left T1. Aren't these the forces in the horizontal direction? We are not marking the forces in the vertical direction because it is not part of our motion or not our interest. वो तो है, but it is not going to help us in finding out any of the unknowns, so we are not drawing it. बस. Net force acting on the body is formula mass into acceleration. Mass कितना? 1. What is the acceleration of this one? Whether it is 1 kilogram, 2 kilogram or 4 kilogram, acceleration is 2 meter per second square. है ना? Net force acting, force towards right 14 minus tension is towards left. So 14 minus T1 is a net force. So can't you find T1? Take T1 to the right hand side. 14 1 into 2 minus 2. So T1 हो गया 12. Understood? अच्छे से समझ में आ गया, कोई गड़बड़ नहीं. So we got the value for T1. ठीक है. How will you find T2? You can take 2 kilogram body, it's up to you, but it will be easy if you take 4 kilogram to find T2. क्योंकि if you take 4 kilogram, the only force acting on this 4 kilogram is T2 towards right. समझ में आ गया? हाँ. Then लिख ले, net force of the body is equal to mass into acceleration. What is the only force acting? T2. That is equal to mass. Acceleration. What is the acceleration? All are having the same acceleration. ये हो गया 8 Newton. So हमको मिल गया T1 value and T2 value. It's not a big deal. समझ में आ गया सबको? सबको अच्छे से समझ में आ गया? बोल दो. भारत, म्यारा, हर्ष. हर्ष किंग. अरे किंग भी है हमारा क्लास पे. ठीक है. ठीक है. Yes, श्रेया. हाँ, hi. Yes. So any doubts you have, please let me know. अरे भारत, same options. Was the option same? अरे मैं तो पता नहीं, है ना? मे बी बिकॉज मेरा कंटेंट पर्सन तो इधर उधर थोड़ा थोड़ा गलती तो हो सकता है. आई एम रियली सॉरी. ठीक है. I'm giving you the points from my heart. Is it fine? The points from my heart with love and care. ठीक है, वो तो ले ले. If you think that that is more valuable, तो अच्छा हो जाएगा, है ना? ठीक है. Now, equilibrium of a body. When can you say that a body is in equilibrium? Okay, we can say that a body is in equilibrium when the net force acting on the body is equal to 0. Tell me, a body which is at rest, which means its velocity is equal to 0. A body which is at rest, and if the net force acting on the body equal to 0, the body will be continuing to be in the state of rest itself, isn't it? This kind of equilibrium we call it as static equilibrium. Static matlab not moving. And a body of mass m which is moving with a constant velocity, v constant, and if the net force acting on the body is equal to 0, in this case what happens? The body will be continuing to move with this constant value of velocity. Force is 0, but the value of the velocity will be constant, or the body moves with a constant velocity. I hope I don't need to explain, right? Force is not required for the body to move with a constant velocity. ये सबको पता है ना? I think from 8th standard, 9th standard or 10th standard. बस. So this kind of equilibrium we call it as dynamic equilibrium. Anyway, if a body is in equilibrium, the net force acting on the body will be equal to 0. ठीक है. Okay, let us do a very simple problem based on this equilibrium. A mass of 6 kilogram is suspended by a rope of length 2 meter from the ceiling, and a force of 50 Newton is applied in the horizontal direction at the midpoint of the rope. 6 kilogram, this was the case. You are applying a horizontal force which is 50 Newton. So what will happen? Idhar to thoda bend ho jayega, and the body will be acting like this, will be in this position. What is the angle between the rope, this is the rope, and the vertical in equilibrium? So this angle is a question. This is the vertical, this is the rope, and the angle between them, this theta. You can make use of the concept of equilibrium. Equilibrium matlab, is the body moving? No, matlab the net force acting on the 0 at this point is 0, है ना? Net force is 0. Just use this concept and we can find out all the unknowns in this particular equation. The first question is find out the value of theta. So for finding out the value of theta, mark down all the forces acting at this point. Which are the forces? 1. T1, a component of T1 which is T1 cos theta. The other component is T1 sin theta. T1 is the force or the tension force in this string. Done. This is W, the weight of the body downward, and here there is an upward tension T2. This is another string, so another tension. Can you tell me what is the relationship between 60 and T2? Array, downward and upward force should be equal because the body is at rest. So T2 equal to 60, we can write it from here. Okay. Coming back to this point, T1 cos theta, T1 sin theta, the applied 50 Newton force, and here a tension T2 downward. Aren't these the forces acting? है ना? हाँ, बिल्कुल. Now start equating the forces. Upward force of T1 cos theta is equal to downward force of T2. Force towards left will be equal to force towards right, 50. Start dividing. Okay. Sin by cos, tan 50 by T2. T2 का value 60. 0 cancel. Theta is tan inverse of. हो गया. समझ में आ गया सबको? समझ में आ गया सबको? Not a big deal. छोटू problem. Okay. So please do mark it down, and this is very important. Okay. Now, before we move forward, shall I take a small break? Shall we have a small break? A small break of 5 minutes. ठीक है. Sana, Miara, Tushar, Sankamitra, Shreya. Yes. Okay. So I'll just use the restroom and थोड़ा बाहर आकर थोड़ा कुछ खाना पीकर I'll come back. है ना? Thank you so much. So everyone, you all can go for a break. Go to your kitchen. Ask your mom is there something to eat. You can also eat something. So I'll also have something and I'll come back. ठीक है? बच्चा लोग, so you all had your food, refresh हो गया? So I just मुझे इधर cafe है, which means an academy. I hope you all, I don't know whether you have seen the Unacademy office. It's so beautiful, and there is an amazing cafe inside where you'll get all kinds of food. So I just went and had a small coffee. Coffee नहीं, actually tea तो ले लिया, and I also got a Snickers. तो Snickers भी ले लिया. ये सब फ्री मिलता है. देख ले कितना कितना. Hi Myara. So tell me what all you had. क्या क्या ले लिया आप लोगों ने? हाँ, वेलकम वेलकम. सर मुझे कल ऑपरेशन क्या ऑपरेशन था तू? हाँ, इन बैंगलोर. सब ठीक है रे तू? आपको इज एवरीथिंग फाइन? अरे वी आर नॉट एबल टू शेयर आवर पर्सनल नंबर्स, दैट्स द थिंग. So shall we start? Are you all ready? Shall we start? So I think now you all might have got some extra energy to start learning. Hi Marian, hi. ठीक है, बस चाहे तो बस. तो हम तो जा रहे हैं to move with pulley mass system. So break time is over, and now it's time for pulley mass system. A pulley mass system, which is one of the most common and one of the important question that you will be finding from this particular chapter. देख ले. These kind of questions you can expect. You will be having a pulley which is hanging from a roof, okay, and from this pulley through a same string you can have masses m2 and you can have mass m1. Let's say the mass m2 is greater than m1. If the mass m2 is greater than m1, can you tell me what happens? The mass m2 will be coming down with some acceleration a, which we don't know. If mass m2 is coming down with some acceleration a, the mass m1 is also connected to the same string. So if mass m2 is coming down, the mass m1 will be going up with the same acceleration. Two kinds of questions can come from this part. If m1 and m2s are given, what are the value for tension acting in the string? As this is the same string, tension is going to be the same, and the question can also be what is the value for accelerations, right? Okay, how will you do it? Whenever you get questions related to force or acceleration, what you all have to do? Yes, draw the free body diagram. Shall I first draw the free body diagram of mass m1? देख ले, mass m1, free body diagram marking all the forces. The first force m1g, downward. Other force tension, and it is moving upward with an acceleration a. Let's write net force of the body is equal to mass into acceleration. Let's start substituting. Force is T, upward, minus m1g is equal to mass of the body is m1. Acceleration is upward, so it is positive. We got our first set of equations. हो गया? हाँ? Then let us take the second body. Second body ले लिया आप लोगों ने? अच्छे से ले लिया? हाँ? with a मुस्कुराहट? ठीक है. M2 पे which are the forces acting? Mark on it. First one is the tension force upward. Then its weight m2g, and the particle is coming down with an acceleration. We can write net forces mass into acceleration. Which are the net forces? T upward, so plus T. m2g is downward, so minus m2g. Net forces mass into acceleration is downward, so minus a. I hope you understood why I have written minus a here. क्योंकि क्योंकि मुझे पता नहीं. I feel it so funny. क्योंकि. Okay, so the body comes downward. Acceleration is downward. Downward direction we usually take it as negative. हो गया. So if you take this negative to the left hand side, how much you can write? m2g minus t is equal to m2a. Second equation, first equation. Array to solve. How many unknowns are there? We have tensions and acceleration. Two unknowns, two equations. Simply solving, right? If you want to find out acceleration, add equation 1 and 2. You have t minus mg, m2g minus t. क्या हो जाएगा? Plus t and minus t will cancel. What remains is m2g minus m1g on left hand side of the equation. Add किया. Now add right hand side of the equation. m1a plus m2a. How much? m1 plus m2 into a. So acceleration का equation from here, tell me. देख ले, acceleration is equal to g is common, m2 minus m1 into g divided by this m1 plus m2 will come downwards. m1 plus m2 हो गया. We got the value for acceleration. Array, if one unknown is got, why can't you find out the second unknown? Simple. Substitute the value for acceleration in either of this equation. वो substitution can I give you? आप तो कर सकता है. देख ले. T minus m1 into g is equal to m1 a. A is here. Substitute it here for acceleration. Do the cross multiplication. You will get the value for t. ठीक है? So the t you will be getting as 2 m1 m2 g by m1 plus m2. बस हो गया. Very important, super important. Make sure that you note down all these things. अच्छे से. ठीक है? Any doubts you have, please let me know. जल्दी. अर्पण, भारत, कोई डाउट नहीं, सब अच्छा हो गया. हाँ, अच्छे से समझ में आ गया. अच्छे से. Then show me that smile. हाँ सर, बिल्कुल, क्यों नहीं, अच्छे से समझ में आ गया. So I'm gonna rub this, okay, and please take a screenshot if you want it. So the value for acceleration is m2 minus m1 into g by m1 plus m2. It's better if you can by heart this, because usually we'll come across this question. And tension is 2 m1 m2 g by m1 plus m2. Okay, fine. Moving on. Okay, so we have a question. A simple Atwood machine. Atwood machine matlab this mass and pulley system, right? हाँ, Menti सब Menti बोल रहा है, Menti. And is that the only person who's telling Menti? Bharat is the only person telling Menti. हाँ, kinetic friction का भी हम तो कर लेगा. इसके बाद we'll be having a inertial and non-inertial frame of reference, and then we will start with frictions, right? Okay, bas we'll be doing. So do you want me to do this as Menti, or should we be just completing the chapter? जल्दी बोल दे. जल्दी बोल दे. Is it only Chuneet who needs Menti, or everyone needs? If everyone needs, we'll be doing it as Menti. Everyone needs. ठीक है. If everyone needs Menti, then why I be the only person to stop you? Good night, Ritu. Jaldi. Fifth question. Those who want to join, those who haven't joined, jaldi join kar le. Sana, my wish. Wow, what a beautiful student I have in the classroom. Whatever is my wish, she's okay with it. Very good. So, yes. जल्दी ज्वाइन कर सकता है तो जल्दी ज्वाइन कर ले. आई वोंट वेट मच, जस्ट बिकॉज यू टोल्ड सर वी वांट मेंडी. ठीक है, मेंडी तो ले लिया. नाउ इट्स योर रिस्पॉन्सिबिलिटी टू कम फास्टर. कोड यू कैन सी 50651291. 50611291. जल्दी 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 जल्दी. सर एक सॉन्ग, अरे मैं क्या क्या कर रहा हूँ इधर. मंडी करना है, पढ़ाना भी है, अभी सॉन्ग भी. अरे यार मेरा गला तो जा जाएगा. Okay, so the number of students in Menti is very less. So I think from next onwards, I don't think I'll be doing Menti. Menti का students बहुत कम है. ठीक है, तो देखेगा. इसके बाद देख कर ही करेगा next वाला Menti. Quickly give your answers. and what is happening in the chat box? अरे रिदु, I have lot much to complete here. If I start singing है ना, मेरा गला तो जाएगा. Thank you, Mishika. Last 20 seconds. Okay, 4 students got it correct. ठीक है, बढ़िया 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 बढ़िया. Very good. Very good, very good, very good. And let me see who are those 4 students. Wow, wow, wow. A very tight competition between all these 4. Miara the fastest on the top. Sophia we have, Sana we have, Puggy we have. Very good. The competition is so tough here. It's good, right? Okay, बढ़िया. Now let's see how this question can be done. It's not a big deal. Not a very big question also. As you can see, okay. So here we have a pulley, and from the pulley 600 gram, right, which is 0.6, mass is equal to 0.6, we know that. And another mass is how much? 600 and 300, that is equal to 0.3, right? So these are the masses which is hanging from the string, and this is our Atwood machine, sometimes we call it, or the mass and pulley system, we usually call it, right? Okay. So the system is released. Find the force exerted by the clamp on the pulley. Can you see this clamp? The question is not to find out any of the tensions or acceleration. The question is to find out the value of force here. The force this clamp will be given on this particular pulley. Okay. For that, you have to draw the free body diagram of pulley. Question is, what is the upward force that is being applied on the pulley by the clamp? कैसे कर सकता है? Mark all the forces acting. Tell me which are the forces acting on this particular pulley. This string will be providing a tension downward. This string will also be providing a tension downward. So tell me, what is the net downward force? 2T, right? Now, in order to find out the unknown force, क्या लिखना है हमको? Net force is equal to mass of the body into acceleration of this particular pulley, right? Isn't it? Yes, तो बिल्कुल. What is the net forces? Upward is F minus 2T is equal to mass into acceleration. What is the acceleration of this pulley? Is the pulley moving? No, it is kept stationary there. It is 0. So this is equal to 0. So F ka value, which means the force provided by this clamp on the pulley is equal to 2 times the tension. Bus 2 times tension ka formula I already have told you. Yes, 2 m1 m2g divided by m1 plus m2. Bus. So 2 2s are 4, right? Into m1 into m2. What is m1? 0.6. m2 0.3 into g 10 divided by m1 plus m2 0.6 plus 0.3 0.9 हो गया. 4 0.3 into 10 is 3, so 4 3s are 12. 0.6 by 0.9, okay, so you take the points away, so it is a 6 by 9, so वो हो गया 2 by 3, right? So 3 goes in 12, 4 4 2s are 8. Option D is our answer. ठीक है, बिल्कुल छोटू छोटू. Yes, 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 yes. कोई गड़बड़? I don't think so, right? So I hope things are clear till this part. Okay, now it's time for frame of reference. Everyone, this is one of the important topic. Important matlab it is super का ऊपर और ऊपर का भी डूपर वाला important है frame of reference. Very important. I want every one of you to listen to me After this, we will be jumping to the part of friction, which will be the last part of this particular chapter, right? Okay. Now, let us understand what is this frame of reference. Let's say that we have a closed container. Okay, this container is closed. Inside we have a person, and this container is moving, let's say, with some velocity or acceleration. This container is moving towards left with some acceleration. Okay. Now, if an outside person calls the person inside this container and asks, "अरे भाई, okay, कैसे चल रहा है?" He will tell that सब अच्छा चल रहा है, लेकिन I am stationary here, right? Because he is inside this closed wagon and he is not knowing that this particular wagon is moving. So he will say that I am stationary. So with respect to him, he is stationary in this particular scenario. But this person will tell through the phone, "अरे भाई, आप तो stationary नहीं है, you are not at rest, you are moving with some acceleration towards left." Now you just look at the difference. What difference, right? With respect to the point of observation, the motion is getting different. With respect to this person, if he is looking at himself, he is looking at himself, or if he is looking at this particular wagon or this particular vehicle, this vehicle is at rest. But if this lady is looking at this particular vehicle or at this person is moving, which means while defining the motion of a body, it is very much important to define the point about which the motion is observed. And that point about which the motion is observed is called as frame of reference. What is it? The point about which the motion is observed, uska naam hai frame of reference. Very important, super important, keep it in mind. Understood? Now, we are going to learn the rest of the chapter by dividing this frame of reference into two. Non-inertial frame of reference, okay, and inertial frame of reference. Those who don't know what this is, I'll write. Inertial frame of references and non-inertial frame of references. I'll tell you what this is, right? Let us take a fresh page. Inertial frames of references are those frame of references which means the point about the observation is being made is either at rest, or if it is having a constant value of velocity, we call it as inertial frame of references. What are inertial frames of references? Those frames of references which is either at rest or which is moving with a constant value of velocity, we call it as inertial frames of reference. देख ले. Now let us see what is the main reason for this classification. Platform. On this platform, we have a body of mass m, okay, which is at rest, and you know that the net force acting on the body is equal to 0 and acceleration of the body is also 0. This is something known, right? Okay. Now the same body is observed by a person who is standing inside a train which is stationary. What will he feel? When this person who is standing inside a train which is also at stationary, he will feel that this mass is at rest, its acceleration is 0, its net force is also 0, right? Whatever is the observation here, actual observation, he will get the same value, which means here Newton's first law is valid with respect to this person who is stationary and look making the observation. Newton's first law of motion is valid. Matlab, or Newton's first law and second law. And second law is valid, which means if the net force acting on the body is 0, the acceleration should be 0, right? That is being valid here. ठीक है. Now we are having another observer, the person standing inside a train which is moving with some velocity v. Tell me, when this person look at this block, what will he feel? I'll give you a simple idea. If you are traveling in a train or if you are traveling in a vehicle, if you look at the surrounding trees, what will you feel? You will feel that though you are moving forward, you will feel that trees are moving backward. Isn't it? The concept of relative velocity. So here the velocity of the block with respect to the person. I hope everyone knows the concept of relative velocity. Formula: velocity of the block minus velocity of the person, right? Velocity of block, is it moving? No, 0. Velocity of person is v. Velocity of block with respect to the person. Matlab, if person is looking at this particular block, he will find that the block will be moving with a negative velocity. Same like if we look at the trees will be moving backward. Similarly, if he look at the block, he'll feel that the block will be moving backward with a velocity of v. है ना? Tell me, is the Newton first law and second law of motion valid here? Is it valid here? Obviously it is valid, because when this person is looking at the block of mass m, the block is moving with a constant value of velocity. Matlab, acceleration is 0 and the net force is also 0. Net force is already 0, and with respect to this person, acceleration is also 0, which means in this case also Newton's first and second is valid. So these are the specialities of the inertial frame of references. The frame of reference which is either at rest or which is moving with a constant value of velocity, Newton's first law and second law of motion is valid. Now let us look at what is a non-inertial frame of references, okay, and what is the speciality of that. देख ले. Same case, block of mass m, okay, which is actually resting here, which means the net force acting on the body is 0 and it is not accelerating also, it is simply resting here, the block of mass m on the platform. Now you have a train. A person is standing inside the train and observing this block which is moving with some acceleration. And that which is moving with an acceleration, that frame of reference, that point of observation, if it is moving, इसका नाम है non-inertial. Let's see why a separate classification is made here. If this person look at this block, can you tell me what will he feel? He will feel that as the person is moving forward, he'll feel that this block will be moving backward with the acceleration of a, है ना? Though he is moving forward with an acceleration according to the concept of relative, right? You will feel, or this person will feel, this mass will be moving in the backward direction with an acceleration of a. How will you write the same? Acceleration of the block with respect to the person. This is the concept of relative velocity. Acceleration of block minus acceleration of person. I hope everyone knows this formula. What is the acceleration of the block? Does it have any acceleration? No, 0. Acceleration of the person is a. Acceleration of the block with respect to the person, which means if person is observing the block, he will find that the block is having a negative acceleration. Now you know that the force acting on the body is 0, but still, though the force acting on the body is 0, with respect to this person, the body is having an acceleration. Is Newton law of motion valid here? Is Newton law of motion valid here? Tell me, is Newton law of motion valid here? देख ले, force acting on the body, though it is 0, with respect to this person, if he is observing, this block is having an acceleration. Is Newton's law of motion valid here? Yes, Meshiga. Yes, I did. Thank you so much for your care and concern. बता, जल्दी बता. Is Newton law of motion valid here? अरे force 0 है लेकिन acceleration 0 नहीं है. अरे Newton law of motion. Newton law of motion is not valid. Newton law of motion is not valid here. क्यों? Because though the force acting on the body is equal to 0, and the body was supposed to be having an acceleration equal to 0, but when this person is observing, this mass is having an acceleration in the left direction. So this is not possible. Force is 0, the body is having an acceleration. This is not at all acceptable. So Newton's law of motion is not valid where? In non-inertial frames of reference. And where all Newton's law of motion is valid? In the inertial frame of references. Inertial frame of references means those references which are either at rest or which is moving with an acceleration, which is having a constant value of velocity. बस इधर तक कोई गड़बड़ नहीं है ना. Now what we are going to do is, let's see what is the pseudo force, okay, and what is the concept of this non-inertial frame, and when non-inertial frame, how can you apply Newton's law of motion? We understood that it is not valid, right? But how we can apply Newton's law of motion, Newton's laws of motion when we are dealing with non-inertial frame of reference. ठीक है, करेगा, देख ले. These are very important. 2%. ये है हमारा रामू, okay, and this is Ajay. Ramu is at rest and Ajay is having an acceleration of 1 meter per second square. Those who want to understand the concept of non-inertial frame and the concept of pseudo force, be here for the next 5 minutes because it will be worth. Let me tell you. Ramu and Ajay. So these are the people who's observing. Tell me what kind of frame of reference is this? This is inertial. This is the observer and his velocity is 0. So he is the inertial frame. And Ajay, who is having an acceleration, he is non-inertial. Okay. These two people are looking at a block of mass m where a force of 10 Newton is applied. Tell me, if Ramu is looking at this 2 kilogram block, acceleration kitna? Force by mass 10 by 2, that is 5 meter per second square. Ramu, who is at rest, if you look at 2 kilogram, the acceleration of 2 kilogram by F by m, 5 meter per second square. Same 2 kilogram. What is it? Same 2 kilogram. If Ajay looks, can you tell me what will be the acceleration of the block with respect to Ajay? If Ajay is looking at the block, it is acceleration of the block with respect to Ajay. How much will it be? Apply the concept of relative acceleration of block minus acceleration of Ajay. What is acceleration of block? 5. Acceleration of Ajay? 1. 4 meter per second square. Which means, in the second case, if Ajay is observing the same 2 kilogram body, he'll feel the body moves with an acceleration of 4 meter per second square. ठीक है. Now, let us try to apply the Newton's second law of motion with respect to Ajay, where net force is equal to ma, and let's see whether it is valid or not. What is the net force acting on this body? 10 is equal to, what is a mass? 2 into, what is the acceleration of this 2 kilogram body when Ajay is the observer? When Ajay is looking at this 2 kilogram, what is the acceleration? 4. Are they equal? देख ले, are they equal? They are not at all equal. And this itself is what we have said, which means in non-inertial, we cannot apply Newton's second law of motion. है ना? Now, tell me, सोच कर बता. We have to apply the Newton's second law of motion wherever it is in the case of inertial or non-inertial, because we need to find the net force, we need to find out the acceleration. So many things has to be found out. So, in order to apply Newton's second law of motion, in the case of non-inertial frame, we will be adding a false force. A false force matlab a force doesn't even exist. It doesn't even exist. But we are adding so that Newton's second law of motion will be valid with respect to non-inertial frame. And that force is called as pseudo force. and that false force, the force doesn't even exist, is called as pseudo. Pseudo matlab false. Okay, so FP, pseudo force ka formula, right? How much is the amount of pseudo force we have to apply on each body in a general way so that the Newton's second law of motion can be made with respect to non-inertial also. Dekh, that is mass of the body multiplied by acceleration of non-inertial frame of reference. Here, what is the acceleration? 1, and with a negative sign. And what does this negative sign shows? Negative sign shows that the direction of pseudo force is opposite to the acceleration of non-inertial frame. Matlab, how can I apply the pseudo force here on this 2 kilogram block, and we can make the Newton's second law of motion valid here? It is equal to mass 2 into acceleration of non-inertial. How much is the acceleration? 1. And what is the direction? Minus 2 acceleration of non-inertial. What's the direction of non-inertial? Towards right. So the direction of pseudo force will be towards left. So this is how we find out the pseudo force. Now let us try the Newton's second law of motion is valid or not. Dekh le idhar. F net mass into acceleration. Which are the forces acting? 10 minus, now we have a new force, pseudo force. 2 is equal to mass 2 into acceleration 4. 8 is equal to 8. Now isn't it valid? Valid हो गया या नहीं हो गया? जल्दी बता. हाँ, अच्छे से समझ में आ गया सबको? Understood everyone? How will we deal with this question? हाँ, valid है ना? ठीक है. So pseudo force, it's a false force, and its equation is mass into acceleration of non-inertial frame. Its direction is opposite to the direction of non-inertial frame. And why we apply this pseudo force or false force? So that Newton's second law of motion can be valid even we are making the observation from non-inertial frame. हो गया तो हो गया, समझ तो हो गया. With a smile, everyone say, हाँ सर, बिल्कुल हमको अच्छे से मजा से समझ में आ गया, बिल्कुल, है ना? और क्या? ओके, तो हम तो आगे चल रहा है, आगे बढ़ेगा, आगे बढ़ेगा हम. Okay. Now, I have to tell you regarding the weight experienced whenever a person is standing inside a lift. Okay. First, let us explain what is the weight and how can you what is actually weighed in the weighing machine. देख ले. ये हमारा weighing machine, right? Weighing machine means the machine which we use to find our weight. The person stand on this. Okay. Now, whatever is your weight or mass, it will be shown in this particular machine. है ना? Now, tell me, what is actually being read by this particular machine? Is it the mg wala or some other thing? देख ले. When you stand on this weighing machine, you will be pushing the weighing machine in the downward direction n, and the weighing machine will be pushing you back with the same amount of force n. Matlab, the force that is experienced on this weighing machine is a normal force, and whatever is a normal force, that will be measured as the weight of the person. ठीक है? So whatever is the value of n, that will be measured as the weight of the person, and we know that in most of the cases normal force will be equal to mg. But is it true all the case? No. Let us understand, or let us take a case. A lift. A person is standing on inside the lift, and this lift is moving up with an acceleration of a. There is a weighing machine, Wm, a weighing machine, and he is trying to find his weight. My question is, will he be able to find out his actual weight, that is mg, or in this case will he be getting a different value? If it is a different value, what is that value? ठीक है, कर ले. Now you know that this person is moving up, and we also know that whenever you start writing down the forces acting on a body, it is very much necessary that you have to define the point about which the observation is being done, whether it is an inertial or whether it is a non-inertial. Don't worry, we will be doing this question with respect to inertial and non-inertial frame, and you will understand what is the relationship between them and what are the differences between them. ठीक है. Now let me observe this particular person who is supposed to find its weight by another person who is standing inside the lift. Now who is the observer? ये बंदा. Who is the observer? The observer is another person who is standing inside the same lift which is moving upward with an acceleration of a. है ना? Okay. Now what kind of an observer is this? He is moving upward with an acceleration, so he is a non-inertial frame. And if this person who is a non-inertial frame is observing this body, how many forces will be acting? One by one. Tell me. First one, as it is a non-inertial, there will be a pseudo force Fp. As the body is moving up, pseudo force is downward. Formula, mass into acceleration. है ना? Mass of the body into acceleration of non-inertial. Other forces, its weight mg. Then the person will be pushing this weighing machine downward, the weighing machine will be pushed upwards. This is it. These are the forces acting on this particular person with respect to non-inertial. Tell me, what will be the acceleration of the person with respect to the observer? ये observer इस person को देख रहा, अरे यार, the observer is looking at this particular person, right? And what will the observer feel? If you are standing inside a lift and your friend is also there, do you feel like both of you are moving upward, or do you feel like actually a friend is moving upward with some acceleration? नहीं. Which means with respect to you, if you are observing, you will find your friend at rest. Which means if this observer is looking at another person in the same lift, हाँ, उसका net acceleration 0 हो जाएगा. Write down. Net force is equal to mass into acceleration, है ना? Which are the forces acting? Upward n, downward ma, downward mg is equal to mass of the body, and what is the net acceleration? An, which means total acceleration with respect to this person. 0, है ना? Because this observer, look at the body, he will find the second person is at rest. 0 हो गया. N का value, taking this to the right, ma plus mg. So how much is it? So the value of a normal force is equal to m into a plus g. So what will you feel? You know that the weighing machine measures the normal weight, normal force. So here in this case, the normal force is not mg, it is m of a plus g, a value greater than your actual weight. So you will feel that when you measure the weight of your body, standing inside a lift which is moving upward with an acceleration a, you will find a bit heavier than your actual weight. समझ में आ गया सबको? हाँ, समझ में आ गया ये? This concept of non-inertial frame, it is very important. Arpan, Myara, Yash, Sudeep, King, Arpan, Sophia, Sudeep, Bharat. हाँ, कोई गड़बड़ है तो बता. If anyone is having any trouble in understanding any of this, please let me know. When coming downward, that is a homework for you. Please do it. You will be getting it as m into g minus a as normal. Right? That is a homework for you. है ना? Revision class है, तो homework तो करना ही पड़ेगा. Okay. When they come downward, acceleration, sorry, normal force छोटा हो जाएगा, which means you will get the value of m into g minus a. Use the same concept and try to do it. What I'm going to do now is, we did the problem with respect to non-inertial frame. है ना. Now ये तो I think everybody have noted, or I think it will be better to write here. देख ले, because if you write on the left hand side by comparing it with this, you'll be understanding in a better way. अच्छे से समझेगा. देख ले. Okay, same lift, moving upwards, person. Okay, you want to find the normal force here. Now the observer is not standing inside this elevator. Let the observer is standing on the ground, which means he is having a zero acceleration. So ये हो गया inertial frame. Now the new observer who's observing the motion is inertial frame. ठीक है, ठीक है, ठीक है. Now let us try to find out the normal force. With respect to inertial frame, which are the forces acting? Only two forces. One is its weight mg, and the other force is upward normal. And it is this normal you want to find out. कर ले. Net force is mass into acceleration. Don't worry, you will get the same answer. Net force is equal to what? The net force? Upward force N minus downward mg is equal to mass into, with respect to this person, isn't the lift moving upward with an acceleration of a? Yes. है या नहीं? Yes, it is moving upward with an acceleration of a. बिल्कुल. So देख ले, n is equal to m into g plus a. You got the same answer. बिल्कुल same. है ना? समझ में आ गया? So you can take inertial frame of reference, non-inertial frame of reference. लेकिन if your concept is clear, you will get the same answer. बस. Okay. So shall we proceed? Okay. So got it. बढ़िया बात है, बढ़िया बात है. Okay. Now अरे मेंटी तो नहीं में आ रहा क्योंकि है ना, there are very less number of students and only 2-3 people are joining the menti. So there is no point in joining the menti. है ना? So we'll stop menti. अरे मेंटी चाहिए? मेंटी मेंटी. अरे ठीक है फिर, ठीक है. So let's see. No menti है ना? Okay, so for those menti lovers, let this be the very last question for menti. I also wanted to do the menti, लेकिन number of students are very less. अरे ठीक है सोफिया. Okay. Okay, so the very last question with menti. After this, this is the last question. So try to perform. Whoever is on the top of this leaderboard, and that person will be declared as the winner of this particular menti quiz. Look, अरे 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 अरे, जल्दी से join कर ले. I accidentally started this. I'm really sorry. Everybody want menti. Sophia needs menti. Sophia, you are like data तो हो गया आपका. Last 50 seconds. जल्दी से join करके आंसर दे दे. I hope you all can see the code. Code is 50651291. Okay. Last 30 seconds you all have. अरे last 10 seconds, जल्दी जल्दी जल्दी. Sir, kal nahi, then we have next class on Saturday. हमारा अगला class Saturday. अरे 6 students got it correct. Seems like I should continue with Mendy. अरे भाई जाइए. And let me see who are those 6 students who got the correct answer in Mendy. Very good. Miara, Sana, Puggy, Sophia. So these are the people. I think these are the usual people who comes and attend the Menti here. ठीक है. Anyway, good. बढ़िया बात है. Good, good, good. If you can understand, it's better. Question. With what acceleration A should the box of figure descend? If it was moving upwards, अरे यार आ जाइए भाई. ये बाय है ना, मुझे तंग करता है सारे टाइम. n is equal to m into g plus a. So if it comes downward, those who want to do jaldi se kar le. So let me do the observation from this non-inertial frame of references. ठीक है. So if the observation is being made from non-inertial, which are the forces acting? One is mg, upward is normal. Now the observer is standing in a non-inertial which is moving downward. If the non-inertial is downward, what is the direction of pseudo force? Opposite to it, upwards. Formula, mass into acceleration, right? Net force is equal to mass into net acceleration with respect to non-inertial. Which are the net forces? N plus ma, upward force. Downward is mg is equal to mass of the body. This is the observer. The observer is standing in the same elevator where the capital mass m is kept. Will he feel that this mass is moving? No. With respect to this person, this mass will be at rest. So the acceleration of this block of mass m with respect to the person ho jayega 0. So n ka value mg will go up right, plus mg ho jayega, plus ma will become minus a, so m into g minus a. ठीक है. So जल्दी फटाफट we have made the derivation. Question तो ये है, with what acceleration a should the box of the figure descend so that the block of mass m exerts a force mg by 4 on the floor of the table? Exerting a force on the floor of the box, what is that? Normal force, and the normal force ka value is given as mg by 4. So you should be knowing what is being told here in the question. Exerts a force on the floor of the box, which means that is a normal force. And substitute here, n is equal to mg by 4 is equal to m into g minus a. M cancels. G by 4 is equal to g minus a. If I take this a to the left, g by 4 go to the right, g by 4. How much? 3g by 4. उत्तर B. आ गया समझ? हाँ, आ गया समझ? Okay, I hope it's not a big deal. So we just have written down the formula and applied the values. Bas. So let us proceed further. Okay. A pendulum is hanging from the ceiling of a car having an acceleration of a0 with respect to the road. Find the angle made by the string with the vertical. I think you might have observed this. A car you have, inside the car something will be hanging, let's say a block, anything of mass m. Okay, something is hanging, and this will be the case when the car is stationary. And when the car starts to move all of a sudden with some acceleration of a0, what can you see? The car will move, the upward part of the string which is connected to the car will also be moving, and because of inertia of rest, this mass m will be stationary here. So once the car starts moving, how will the block be looking like? Won't it be looking like this? Hannah, by making some angle of theta? Yes. The question is, find out the angle made by the string with respect to the vertical. कैसे कर सकता है? You can do it in different ways. I am doing it. This is a car with respect to you. Matlab, you are sitting inside the car, in the same car which is moving forward with an acceleration of A, and you are looking at this particular bob which is hanging. First tell me, with respect to you, if you look into this particular, you are traveling inside your car and you are looking at that particular bob which is hanging. Will you feel like it is moving? No, you'll feel like it is hanging there stationary. Matlab, what will be the net acceleration? With respect to the person, net acceleration is 0. है ना? ठीक है. Now start marking all the forces acting on this bob of mass m with respect to this person. Which are the forces? First, weight, then tension force along the string, then ye having an acceleration, the observer is having an acceleration, so what kind of body it is? He is a non-inertial frame of reference, hai ya nahi? Yes. So if he is a non-inertial frame of reference, a pseudo force will be there, direction opposite to non-inertial. Non-inertial is moving towards right, so opposite is this, and value is mass of the body into acceleration of non-inertial, ma. ठीक है? So we have marked all the forces. Now write net force is 0. Why net force is 0? Because you know that the body is having an acceleration of 0 with respect to the observer. ठीक है? और कुछ नहीं किया मैं. Now what you have to do? You have to start resolving. ये theta, ये theta. So ये हो जाएगा t cos theta. ये t, ये theta cos component. ये t का sin component. It's at rest with respect to this person. So force towards right will be force towards left. Kitna? Pseudo force, ma. Force upwards will be force downward. With respect to the person, bob is at rest. So forces acting in each direction will be 0. So force towards right will be equal to force towards left because the body's acceleration in the x direction is 0. So t sin theta ma. Body is not even vertically moving. So upward force, downward, t cos theta equal to mg. Now, what is the question? Question kya hai? To find angle. Divide 1 by 2. T cancel. Tan theta. Cancels. A by g. Theta हो गया tan inverse of. बस कोई है उत्तर? Option C. बस. Yes, Myara has already given the answer. Who has given the answer? Arpan, yes, divide. Very good, very good. You are right. बिल्कुल बढ़िया. और कोई आंसर दे दिया? मानसी दे दिया, देविका, then अरे very good, very good, very good. How long the session? I think we are only left with friction now. Friction तो बाकी है भाई, और कुछ तो नहीं. Which means let's say 45 minutes more. We'll have 45 minutes more. Last 45. Which means, like I said, by 12 o'clock we'll be completing. Okay? Yes? Menti, okay, after friction we'll, if we have enough students in the class, we'll do the Menti. ठीक है? Now shall we understand friction, which is very important concept? ठीक है? Let me show some energy. It's already 11. अरे tomorrow Saturday है ना? तो थोड़ा और. Okay, friction अभी. Let us understand about the concepts of friction. Listen to me. It is very, 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 very important. Okay, this is our surface. On the surface, we are having a block of mass m which is resting. You know that these two surfaces look so smooth, but however smooth the surfaces may look like, there will be some chotu irregularities, which mean if you have or if you magnify this particular surfaces in contact, how it actually will be looking like will be like this. There will be irregularities on the surface of the block, and there will be irregularities on the below table also. Now let's see what happens. Now when you are not applying any force, and if the body is not having any tendency, they'll just be lying like that. There won't be any interlocking of those irregularities. Okay? Which means you just look at my knuckles. Can you see? You can also take your knuckles and you can place one knuckle over the other in their dips. Now, is there any force acting between those knuckles in the horizontal direction? No. But when can you experience a force in the knuckles? When you try to move one of your fist over the other. When you try to move, you can see that these irregularities will be interlocking. Similarly, if these two are resting, one will be over the other irregularities. There won't be any interlocking. But let's say if I apply a 1 Newton force on this body of mass m, this body of mass m will try to move over the other. Then what happens? Just like when fists try to move over the other, the interlocking of this irregularities happen. Similarly, here also this irregularities will be interlocking and will be trying to provide a resistive force. And this resistive force is called as what? Frictional force. So how frictional force is produced? Because of the interlocking of the irregularities. Will there be interlocking of the irregularities when the body is not moving and when we don't apply any external force? No. Which means when the body is at rest as such, okay, and when we don't apply any external force on the body, frictional force is zero. But the moment you start applying a force on the body when it has a tendency to move, the irregularities will be interlocking, which produces a resistive force, which is called as friction. Right? Is it necessary that the body should move when you apply 1 Newton? No. If the friction has a capacity to provide 1 Newton of force, which is as applied by the external, will the body be moving? Not at all. If the friction can provide or if it can produce a resistive force of 1 Newton, which is equivalent to the external, the body will not be moving, right? We know that. Dekh le, pen. If I apply small force on this pen, it won't be moving. Why? Because the frictional force between the pen and the palm is providing an equal amount of resistive force. It won't move. And this frictional force acting between the surfaces when one body is not moving over the other but has a tendency to move. This body has a tendency to move towards, right? But it is not moving. That kind of frictional force is called as static frictional force. What do you call this? We call this as static frictional force. And if you plot a graph between frictional force and the applied force, when you apply 1 Newton, the frictional force is also 1. Let's say I am applying 2 Newton. What will happen? If the friction has a capacity to produce a 2 Newton, a friction will also be producing a 2 Newton force, which means if you apply 2, and the frictional force will also be producing 2. Let's say the maximum frictional force that can be provided is 10 Newton. Okay, the maximum frictional force that can be provided by the interlocking of this irregularities is 10. So let's say if I apply 3 Newton, what will happen? If I apply 3, the frictional force will also be providing 3. 4, 5, 6, 7, 8, 9, 10. Till you apply 10 Newton, okay, the frictional force will also be providing the same amount of force and the body will not be moving. So what you can understand regarding the property of static frictional force? Regarding the property of static frictional force, you can say that if I apply 2 Newton, frictional force is 2. If I apply 3 Newton, frictional force is 3. If I apply 10 Newton, frictional force is 3. Sorry, 10. frictional force or the static frictional force in specific is a self-adjusting force. Matlab, it keeps on changing its values according to the external force you apply till the maximum force of friction. Till the maximum frictional force that can be applied between the body's frictional force will keep on changing according to the external force you apply. So you can say that frictional force is a self-adjusting force. Now tell me, according to our example, the maximum frictional force is 10, let's say. Hana, if I apply 11 Newton, what happens? The body will start moving. And when the body starts moving, obviously there will be still irregularities will be interlocking. And that frictional force we call it as what is it? If you apply a force greater than the maximum value of static frictional force, the body moves, and then the frictional force acting between the surfaces in contact, we call it as kinetic frictional force. What is it? Kinetic frictional force. Keep in mind. Tell me, which frictional force will be greater? Is it the maximum value of static frictional force, which is 10 Newton, or when the body starts moving, the frictional force acting at that point, which means kinetic friction? Which one will be? You also know, to make a body move, you have to apply a larger force because the static frictional force maximum value is so huge. Static frictional force is so huge there. But when the body starts moving, don't you think that once it moves, to keep the body in motion, it's not a big task? Kyun? Kyunki kinetic friction is not so huge. Matlab, if you continue with the graph here from the maximum value of static, right? If you apply a force greater than that, how will the graph be? Aise. Why? Because if you apply a force of 11 Newton, the frictional force acting will be kinetic friction, which will be a value lesser than the maximum value of static frictional force. समझ में आ गया? समझ में आ गया? Understood everything related to this frictional force? सबको? सबको समझ में आ गया? We have understood there exist two kinds of frictional force. When the body is not moving, and only when there is tendency for the body to move, what we have is static. And static frictional force is self-adjusting force according to the external force you apply. Second concept. Then this will keep on changing its value. Static frictional force will keep on changing its value until it reaches the maximum value. We call this maximum value of static frictional force as limiting frictional force. Keep this in mind. Okay. And if you apply an external force greater than the limiting frictional force, right, what happens? The body starts moving. And when the body starts moving, the frictional force acting is called as kinetic friction. Which will be greater? Is it the limiting frictional force or the kinetic? We know that when the body starts moving, friction will be less. So kinetic friction will be lesser than the maximum value of static friction, which is limiting friction. समझ में आ गया? छोटू छोटू बातें? हाँ, ठीक है. Now, let us understand what is the equation for the frictional force. A body of mass m. Now, tell me, when will the frictional force will be more, or how the frictional force is produced? Because of the interlocking. है ना? There is irregularities. There is irregularities. These two irregularities interlock each other. The frictional force is produced. Yes or no? Yes. And you know that if more is the interlocking, more will be the frictional force. And how can this interlocking be more? If these two surfaces push each other more. If they push each other more, interlocking will be more intense and frictional force will be more. Tell me, what is that pushing force called as? Pushing force is called as the normal force. So, frictional force produced is directly proportional to the normal force. Why? Because if the normal force is more, the pushing force between the surfaces is more, and more will be the interlocking or the intensity of interlocking, and so the frictional force will be more. Frictional force is equal to, converting proportionality into an equation, frictional force is equal to mu times N. And what is this mu? Coefficient of frictional force. What is this? Mu is called as the coefficient of frictional force. Make sure that if you are finding static frictional force, this will be equal to mu s into n. What is mu s into n? Coefficient of static frictional force. And if you are finding out kinetic frictional force, there you have to use a coefficient of kinetic. Mu k into n. What will be mu k? Coefficient of kinetic frictional force. Bas. This is the equation for static and kinetic. Lekin, I know that every one of you can have this chotu doubt. The chotu doubt every one of you can have is, sir, you told us static frictional force keep on changing its value, which means if a graph is plotted between the external force applied and the frictional force, graph was looking like this. Then how can the static frictional force can have a specific value of mu s into n? It keeps on changing its value. This mu s into n, the static frictional force, the equation for static frictional force is actually the equation to find out ye. What was ye? The limiting. Matlab, mu s into n will be giving you the maximum amount of static frictional force that can be provided between the surfaces. And obviously we know that static frictional force is a self-adjusting force, and it keep on adjusting its value till it reaches the maximum value of static friction available, which can be found out by using this formula of mu s into n. Very, very super ka duper ka important formula. Write it down, everyone. Note down. S4 static, K4 kinetic. Please note it down. Okay, Arpan. How to determine bodies are at rest or motion? For that, you just have to go for the Newton's second law of motion. Net force is equal to mass into acceleration. If there is a net force acting on the body, yes, there will be an acceleration on the body. Okay? Yes. Is it clear? Koi gadbad nahi. Shall we proceed? Okay. Now, the next thing. The next thing which everyone can have an issue with is how to find the direction of this frictional force. What is the direction of frictional forces will be? I'll tell you. This is a table. On this a block of mass m is there. Okay. Now the direction of friction. Direction of friction is always opposite to the relative velocity. Matlab, body of mass hai. Let's say if it is moving with some velocity of 5 meters per second. Okay, this table, it's at rest. Now you have to find out the direction of frictional force acting on the block of mass m and on the table. So to find out the direction of frictional force acting on this big block of mass m, what do you have to do? You have to find out the velocity of this block with respect to table. Formula: velocity of block minus velocity of table. What is the velocity of block? 5 minus velocity of table is 0. So this is 5 meters per second, which means in the positive direction is the velocity of block with respect to table, and direction of friction is opposed to the opposite to the relative velocity. So what will be the direction of velocity acting on this body of mass m? Towards left. Understood? The direction of friction will be towards left. Similarly, What will be the direction of frictional force acting on this block, on this table? For that, you have to find out the velocity of the table with respect to the block. Velocity of table minus velocity of block. Velocity of table is 0 minus velocity of block is v minus v. Matlab, the relative velocity of table with respect to the block is minus v, which means towards left. So the direction of friction is always opposite to the relative velocity, which means towards right. Okay, this is how you find out the direction of friction. Okay, the direction of friction is always opposite to the relative velocity. But when you are asked to find out the direction of friction acting on bodies which are in connection, you don't have to separately find out the direction of friction on both the bodies. If one of the body is experiencing a force towards left, the other body which is in connection to it will be experiencing the frictional force towards right. That's it. Keep this in mind. Okay, understood? समझ में आ गया? Now finding this is not a problem, but finding the friction in that case, it's not a big deal. In this case, this is moving with 3 meter per second and this body is moving with 5 meter per second. Tell me, what is the direction of friction force acting on this 3 meter per second? Towards right or towards left? Who can tell me? Direction of frictional force. Direction of frictional force acting on this 3 meter per second body, whether it is towards right or left. Use the concept which I have told you. Direction of frictional force is always opposite to the relative velocity. So you say it is towards left. Towards left, Arpan says, Tamanna says, Sana also says it is towards left. अरे ठीक है. Now let us see. Let us understand. Fine. Let me find out the relative velocity. Let's say this is block A and this is block B. We know that the direction of friction is always opposite to the relative velocity, right? For finding out the direction of friction on the block of A, I have to find out the velocity of A with respect to B. Formula: velocity of A minus velocity of B. What is velocity of A? 3 minus 5. How much is it? Minus 2. So what is the relative velocity of A? That is towards left. So what will be the direction of friction on the body? Friction on the body A will be towards which direction? Towards right. You can use your common sense also to find this out. कैसे? A is 3, B is 5. मतलब who will be moving faster? B will be moving faster. देख ले. Two bodies. If my bottom palm moves faster, in which direction the bottom palm is experiencing a force? Bottom, which is moving faster compared to A, or the upper one, will be experiencing a frictional force in this direction. है ना? And what is the direction of frictional force on the upper palm? What is the direction of the upper palm which you are experiencing? That is towards right. Understood? It is better to go with this so that you won't be finding any confusion. समझ में आ गया अभी? हाँ, clear? अब समझ में आ गया? Understood what is the doubt? हाँ, Sana, you are right. Now right, okay. Now सब right हो गया, है ना? Okay. A small question. A छोटू सा question. Okay, so question कर ले. A block is projected along a rough horizontal road with a speed of 10 meter per second. If the coefficient of kinetic friction is 0.1, how far will it travel before coming to rest? Let's see. block, okay, sorry, surface, a block which is moving with a velocity of 10 meter per second. ठीक है. If the coefficient of kinetic friction is 0.1, if this is moving forward, what is the direction of frictional force it will be experiencing? F will be towards left. Formula mu k times n, because it is kinetic friction, right? Okay. Next, after some time, it will be coming to rest. Question is, before coming to rest, how much distance it covers? Basically, the equation you have to use is what? V u displacement. Formula V square is u square plus 2as. है ना? V is 0. U square is 10 square. Acceleration is in which direction? Array, force is towards left. So acceleration is also towards left. So opposite to motion it is. So minus 2as. So S is equal to 10 square by 2a. लेकिन acceleration is unknown. है ना? You want to find out acceleration. How? Acceleration. Actually here it is a deceleration, okay? But anyway, let's find out its magnitude. Acceleration is equal to net force divided by mass. What is the force acting? Mu k times n divided by m. Anybody is having any doubt to find out the normal force? Array, in the horizontal direction, force is mg downward and upward is normal. Is a body making a motion in the vertical direction? बिल्कुल नहीं. So upward force of n is equal to downward of mg. So n is equal to mg here in this case. So I can substitute n is equal to mg divided by m. M cancel. This is mu kg. This is equal to mu k कितना है? 0.1. g हो गया 10. So ये हो गया. ये हो गया how much? 1. And what is this? Mu kg is equal to 1. What is it? Acceleration. So we got the acceleration is equal to 1. Substitute 100 by 2 into 1. Not a big deal. है ना? Chotu is a question. It is option C. How many of you have given? Sana, very good. Then Sudeep, Sophia. Very good, very good. Okay, very good. बढ़िया बात है. Okay, so any doubts, anyone? Okay. Any doubts? Anyone? कोई doubt है तो बता. Nothing? Is everything fine? Okay. Okay. Now let us learn about angle of friction, angle of repose, and then we'll be going to the very final part of this chapter, right? Which means, like we said, we'll be completing the chapter by 12 o'clock. Anyway, now we have to see what is angle of friction and angle of repose. I'm applying an external force equal to the limiting frictional force. So if the body is given a force towards right, which is equal to mu s times n, an equal amount of frictional force which is equal to mu s n will be produced. है ना? Yes. And you know that an upward normal force also exists on this body of mass m. What is it? An upward normal. Add these two forces. Which all forces? The normal force and the frictional force, which is mu Sn. If you add, how will you add? This is a triangular law of vector addition, right? According to triangular law, if you add the diagonal of the parallelogram will be the resultant. है ना? Yes. Look at the resultant making an angle with the normal. Can you see? Huh? So take tan of that angle. Tan of theta. How much is it? Opposite. This is mu Sn. So ये भी mu Sn divided by tan theta is equal to opposite by adjacent. On the adjacent, which force is there? N. ये हो गया mu S. ये angle है ना? This angle formed between the resultant and the normal, we call it as angle of friction. And tan of angle of friction will give you the value of mu S. Okay, tan of angle of friction will be equal to mu S, which is the coefficient of static friction. Very important. Okay, any doubt? कोई डाउट नहीं है ना? अरे कितना सिंपल है. ठीक है, अगले. Okay, next concept देख ले. Next is angle. Okay, next is also about an angle, but this is angle of repose. Look here, there is an inclination, an angle of theta, and a body of mass m is on it. Okay, if a body of mass m is actually resting on this inclined surface, let us mark the forces. mg, 1. Normal force perpendicular to the surface is in contact, upward. And if I take the components of this m, this is theta, ये तो theta है, so this is mg cos theta, and downward mg sin theta. You can see that if this is a smooth surface without any friction, because of the component of mg sin theta, the body will be coming down. But if it is a rough surface, if the body is having a tendency to come downward, there will be a frictional force. So will it be coming down? Right? It will not be coming down until the downward force of mg sin theta is greater than the frictional force. Until then the body will be at rest. है ना? Okay. Now what I'm going to do is I'm going to increase this inclination. If I increase the inclination, what increases? Theta increases. है ना? Theta increases, what will be increasing? Sin theta value will increase, because sin 90 is 1, and if we increase the value of theta, sin theta increases. So mg sin theta, the downward force will keep on increasing, right? I'm keeping on increasing the inclination at a particular point of time. The downward mg sin theta will be equal to the maximum value of frictional force, and the angle of inclination at that point of time, we call it as angle of repose. What is angle of repose? It is the angle of the inclination when the downward force mg sin theta is equal to the upward maximum value of frictional force, which is equal to mu times n. What is n is equal to? N is upward, there is no motion in that direction, so upward n will be equal to downward mg cos theta. So on inclination, n is not mg, it is mg cos theta. So this is mu times mg cos theta, right? mg cancels, sin by cos, or if you want to write one more step, sin by cos tan theta is equal to mu, which means tan of angle of repose is equal to mu. Okay, understood. Now tell me, before we make the comparison, if I increase the angle from this angle of repose a bit larger, थोड़ा ऊपर किया तो what happens? When the angle of inclination is a bit larger from this point, mg sin theta will be larger than the maximum value of frictional force. Then what happens? Yes, the body will start coming down. or we can say that the angle of repose is a point where the body is just about to move. Why? Because from this point, even if we slightly increase inclination, the downward force of mg sin theta will be larger than the frictional and the body will start coming down. Okay, ठीक है. Now tan theta is equal to mu. What was tan theta? The angle of repose. Do you remember? Tan of angle of friction was also equal to mu. Tan of angle of friction was also got as mu. Now tan of theta, which is angle of repose, is also equal to mu. मतलब क्या है? राइट हैंड साइड तो सेम है तो लेफ्ट हैंड साइड भी सेम है. मतलब एंगल ऑफ रिपोज is equal to angle of friction. Another important concept, another super important बढ़िया वाला important concept. Okay, very 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 super 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 and duper का important. Okay, so one last concept and then we will be ending our class. 15 seconds. So just like I promised, till 12 o'clock. Circular motion, right? Let's do it. ठीक है, ready है? I know that already many of you have left the class because I know that everyone is already sleepy. ठीक है, let's see. Circular turning of roads. You know that, or those who have seen the racing tracks or racing, you might have seen that when these racers are taking the turns, they will be thrown out of the curve, right? Don't you want to know why this happens and what are the precautions to be taken whenever a person take a turn, right? Let's understand. Now, let's say that a person was moving forward in a straight line, okay? And this person moving in a straight line suddenly has to be a part of a circular motion, which means the person now started to take a turn. Okay, now when this person is taking a turn, he is actually a part of circular motion. And we have learned in the part of circular motion, if any body is making a circular motion, what should be there? An acceleration should be provided toward the center. And what do we call that acceleration? We call that as centripetal acceleration. Formula v square by r. Motion in a plane, we have learned about this, है ना? ठीक है. So there should be a centripetal acceleration. If there is an acceleration, a force should be there, that is mv square by r. Force, centripetal force is equal to mass into centripetal acceleration. मतलब a body which is making a circular motion should be given a centripetal force. I'll give an example. Let's say that you have a stone tied to a string. Okay, this is the center. And above the center, you are making a horizontal circular motion of this particular stone. Doesn't this has to be provided a centripetal force of mv square by r? Yes. Tell me who is providing this necessary amount of centripetal force? It is the tension. है ना? It is a tension force is providing the necessary centripetal force here. So whenever a person is taking a circular motion or whenever a person is taking a curve, he is also a part of circular motion. So he should also be given a necessary amount of centripetal force. And when the centripetal force is not given, or if it is not available for the body which is undergoing this circular motion, or when he is taking a turn, if that person is not able to provide the centripetal, he will be thrown out. When will that person be thrown out? If FC is not provided. If centripetal force is not provided, the person will be thrown out. इधर तक समझ में आ गया? Okay. Now let us see which are the forces available and which are the different methods by which this centripetal force can be provided. ठीक है? देख ले, अच्छे से देख ले. Now a person which is moving in a straight line is taking a curve. Okay, ऐसे curve कर रहा है. Now we know that he should be given the necessary amount of centripetal force. Now it's a plain road, a normal road, and he is not leaning and he is moving straight. Can you tell me which is the only force available to provide the necessary centripetal force? Yes, as there is a tendency for the body to get thrown out of the curve, a centripetal force will be provided by the frictional force, right? So when no other force is available, the only force that is there to provide the necessary centripetal force is equal to frictional force. And what is the formula for centripetal? mv square by r. And the maximum amount of frictional force available is equal to mu times n. This is mu times mg. mv square by r is mu times ng. So the maximum value of velocity with which the particle can take this circular motion is equal to cancel, r goes up, mu rg with a root. So this is the maximum value of velocity with which the particle can take a curve when only frictional force is available. समझ में आ गया? अच्छे से समझ में आ गया है ना? और क्या सर? बिल्कुल. Now this is clear. Let's say that frictional force is not available. Formula is V is equal to root of mu rg. ठीक है? Frictional force तो available नहीं है. But you might have seen this case, which means the riders, whenever they are making a race, they'll be leaning ऐसे toward this curve. What is the need of it? Because now when these people are leaning like this, when the people are leaning like this, they are making an angle theta with the vertical. What is the use of leaning? It's very simple. Because when they are leaning, this is the surfaces in contact. So the person or this bike will be pushing the floor in this direction, normal force, and the road will be pushing the person in the same direction, which means the normal force का direction change हो जाएगा अभी, because now the surfaces in contact is a bit tilted or inclined, है ना? Now take the components, n cos theta, take this component, ये हो गया n sin theta. Now tell me which force is available to provide the necessary centripetal force? A force towards center. Huh? Who is there? N sin theta. Array, now the n sin theta will be providing the necessary centripetal force of mv square by r. And what about n cos theta? Is there any value you can equate n cos theta equal to? Or kya? Upward n cos. Array, downward force is there mg. Vertical, which means the weight of the body will be always vertically downward. उसमें कोई change नहीं है wherever it is. So n cos theta will be equal to downward mg. ठीक है? First, second, divide first by 2. n cancel, sin by cos हो जाएगा. और क्या? बिल्कुल tan, cancel, v square by rg. हाँ. Next, v equal to rg tan theta or v equal to root of tan theta. So when there is no friction and instead you are leaning to make some angle with the vertical, the maximum velocity with which you can take the turn is root of tan theta rg. Okay, so I think I'll just proceed further. I hope you all are understanding, है ना? है ना? Hare who's? Hi Anirudh. Sudeep is like, sir, please drink some water. Eh? Thank you so much for the care. Okay, I'll drink some water. Thank you. Okay. Now, two more concepts, bus, done. Okay, 10 more minutes, we are done with our class. Now, there are other methods also to provide the necessary centripetal force. The other method is, yes, banking of the road. Okay, what is this banking of the road? Usually, we'll be having the road as this. It will be a plane and we'll be having the vehicle moving as a. Okay, the vehicle will be taking a turn and the road will be actually planar. But in usually, when you go to the racing tracks and all, you will find out that the outer edge of the road will be a bit tilted upward. The road will be looking like this, and this is called as banking of the road. Those who are not able to understand, I'll show you the figure. Dekhle, here when they are taking the turn like this, right, the roads are supposed to be horizontal, but you will find out that the outer edge of the road will be a bit tilted up. So this is called as banking of the road. Okay. Now let us understand what is the use of banking of the road. Dekhle, the road was supposed to be horizontal like this, but the roads will be tilted. Aise. Now this is the road and the vehicle will be moving aise. Okay, this is the side view of the road. This is the side view if you are looking like this, and the vehicle will be moving aise. Vehicle will be moving aise on the road. Okay. Now let's see in this case, how can you find out this is theta? Okay, how can you provide or who is providing the necessary centripetal force? Mark down the forces. Mg downward. Then normal forces upward. You want to find out that force acting toward the center. Though it is tilted like this, where is the force acting? The force is acting, the centripetal force, the center is in this direction. I hope you all can imagine. Just think about it. The road is SA. Okay, and this will be towards center. So this is the direction which centripetal force has to be provided. Who can provide? Take the components of this n. ये theta हो जाएगा तो ये theta हो जाएगा. So ये n है तो ये n cos theta है. So ये हो जाएगा n sin theta. है या नहीं? So tell me, in this case also, who is there to provide the force? N sin theta is there to provide the necessary centripetal. N sin theta is there to provide the necessary centripetal and upward force. Is there any motion in the vertical direction? Upward? बिल्कुल नहीं. So that will be equal to downward mg. Divide 1 by 2. N cancel. Sin by cos हो जाएगा. हाँ. Tan theta. M cancel. What is there? V square by rg. Tell me what is the equation for velocity? The maximum velocity with which the particle can go over here is root of tan theta rg. Bas. Okay. Even in this banking of road, the maximum velocity with which the particle can go is root of tan theta rg. But here we are only considering the banking of the road, right? Which means the banking of the road is giving the maximum amount of velocity tan theta rg. But you know that whenever there is race tracks and all, they need more amount of velocity. If they want to be having more amount of velocity, there should be a greater amount of force, right? So if there is greater amount of force only, there can be a larger value with the particle can take that curve, है ना? So which is the other available force to provide the necessary centripetal force in this case? Tell me. I won't be doing the derivation for this one. Okay, you can do the derivation. I'll just be telling you the final formula. Same banking road. Okay, this is the block or any person which is taking the turn. Let us mark all the forces which you already have marked. Mg, n, the components, this is n cos theta and n sin theta. We have done this till here in the previous. Now we want to move faster. If you want to move faster, there should be some other force also acting. What is the force available? Bilkul. The force available is the frictional force. If the body is having a tendency to thrown out of the curve, frictional force will be acting downward. Take the components of friction. ye theta alternate ye theta. So other component downward. So this is f cos theta and downward is f sin theta. Now dekh le, the force which is available here toward the center direction is more in this case. If more is the force, more is the amount of velocity with which the particle can take the curve. And here v is equal to root of mu plus tan theta into Rg by 1 minus mu tan theta. Okay, अरे मेरा जान तो गया. हो गया तो हो गया. तो हो गया भैया लोग, मेरे भाइयों और बहनों, मेरा बच्चा लोग, हो गया. And it took exactly 4 hours for this chapter to get completed. So tell me, when we started the class there were 50-55 students were live. So everyone was like सोने को गया. I think now we have 13 students, है ना? Good, good, good. सॉन्ग चाहिए अभी मुझे, जान ले ले सोफी अभी. 4 घंटे आई वॉज टॉकिंग एंड मुझे बोल रहा है कि सॉन्ग कर ले. अरे यार, इससे बेहतर मुझे ले ले, जान ले ले मेरा. है ना? और क्या. तो समझ में आ गया सबको? So I never done a class for 4 hours. This is my first time. Okay, this is my very first time me taking a class for 4 hours. I never thought this would be possible. Lekin I thought like, students are having the term one examination and why can't I do a revision like this? Maybe it can help them, है ना? So yeah. Umbrella problem, वो तो 2 dimension है. So when we do the revision of 2 dimension, I'll do it. ठीक है. Umbrella problem question is from 2 dimension, not from laws of motion. Thank you so much. So thank you everyone. Okay, so you can share the session to your friends also, those who want to see this and those who can learn, right? So I'm giving a small task to all my various. This is a small task. You just share all these classes to your friends. ठीक है? मज़ा आ गया? ठीक है, बढ़िया बढ़िया, amazing. So thank you so much. I think this is the time to end the class, है ना? So yes, thank you so much. And let me tell you, a crash course for term 1 is going to happen. And I'll be taking physics. Me and Anurag sir is there. Then Vivek sir will be taking chemistry. Nikki ma'am is there for maths. And Pranjay sir is for biology. Right? If you wish to make the crash course and get a very good score for the term 1, you can come and join. Okay? It will be you have to make a plus subscription. And these are the other batches which you can see. And those who have haven't liked the session, jaldi se fatafat like kar le, and do let me know that you have understood and enjoyed the session. And thank you so much. Thank you so much, Sana, for those amazing words, right? So yes, thank you everyone. Okay, so thank you so much for being here, and you can just you can also subscribe so that you'll get all the notification. So why? Let me go and take some rest. I'll be just going to my home. I'll be like going to my bed just like that. So bye everyone, and thank you for being here for the complete 4 hours. Okay, bye everyone, take care.